Saraswati? Saraswati, madam?
Yes, ma'am.
Ma'am has joined. Just check
Okay,
it.
ma'am. Sure, ma'am.
Yeah, good evening.
Yeah, ma'am, good evening, ma'am. Shall we start the session, ma'am?
Yes, ma'am. Yes. And I think you have to make me as a presenter.
Yes, ma'am. We have already made it. You made it, ma'am.
Yeah.
Just a minute, ma'am. Participants, please turn on your video for 5 minutes, please. Ma'am, shall we wait for a few more minutes, ma'am?
Yeah, sure.
Yeah.
I'm not able to make my video on.
Okay, ma'am. Participants only, ma'am. Just we want to take some screenshot. Participants, please. Participants, please turn on your video for a few minutes. Hope Nancy has joined. Okay, shall we start? Yeah. So good evening, everyone. So I welcome you all again for the 4th day faculty development program on exploratory data analytics, tools and techniques supported by AACT. I request our department faculty, Mrs. Nancy Deborah, to introduce our today's resource person. Nancy, please.
Good evening, one and all present here. Am I audible, ma'am?
Yes.
Yeah. Good evening, ma'am. It's a great privilege and honor.
Just turn on your video, Nancy. Yeah.
So it's a great privilege and honor for me to introduce the resource person of today.
Nancy, voice is breaking. Nancy? It's not audible. The inconvenience, ma'am. Just a minute, ma'am. Nancy, Saraswati, please check it.
Ma'am, I'll call her, ma'am.
No, it's not audible, done. What about Nancy?
I'll call her, ma'am.
Ma'am, am I audible, ma'am?
Yeah, now audible.
Ma'am, sorry for the inconvenience caused. Actually, it got unmuted by itself. That's why. Sorry, muted by itself. That is why. So I take this moment as a great privilege and honor for me to introduce Dr. S. Chitrakala, the resource person of today's session. Dr. S. Chitrakala is a professor in the Department of Computer Science and Engineering, Anna University CEG campus, Chennai, with around 30 years of teaching experience. Ma'am is the director of CIT, that is Center for Immersive Technologies, and professor in charge for AIC AU Incubation Foundation, Anna University. Ma'am graduated her BE and ME from University of Madras and PhD from Anna University in the area of image mining, and her main research areas are data mining, computer vision, AI, machine learning, and so on. Her research contributions have culminated in around 161 publications, which include 60 international journals and 88 international conferences and 13 international national conferences. She has visited Bangkok, Australia to present research papers in international conferences, and she is a recipient of Dr. Sharvapalli Radhakrishnan Distinguished Professor and Researcher Award 2022, Best Research Award 2018, Women Researcher Award 2000, Bharat Vikas Award 2017. So these are all some of the few of the many awards she has won, and she is the vice chair for the Chennai ACMW chapter, and she has organized more than around 20 plus short-term programs and conferences in both national and international journals, and has delivered more than 90 plus guest lectures in various reputed universities and institutions. Ma'am is the principal investigator of funded research projects from ISRO during 2020-22. CMRG project 2025 to 2028, and she's the principal consultant for consultancy project on artificial intelligence. And ma'am is holding a granted Indian patent, and three patents have been filed. She has received NVIDIA GPU grant under Academic Seed Program 2. She was a university coordinator and technical committee member for ATAL Incubation Center, Anna University, that is funded by IAIM, that is ATAL Innovation Mission, under NITI Ayog, that is Government of India, with the granting support of rupees 10 crores. She was the CEO in charge and now professor in charge and one of the board of directors for AICAU Incubation Foundation, Section 8 company in Anna University. Ma'am is the nodal officer for establishment of centralized data management center for ICRFT, funded with 30 lakhs under Tamil Nadu Chief Minister Fund. 11 scholars have completed PhD under ma'am's guidance, and she's currently guiding 6 research scholars in Anna University on a full-time basis. She's the reviewer for the various reputed journals, and also she has served in the program committee of several premier international conferences, and she is a professional ACM member, life member of ISTE Delhi, and life member of CSI. It is a great privilege and honor for us to have you as the resource person here, ma'am. I now hand over the session for your valuable speech, ma'am. Thank you.
Yeah, thank you, Nancy. Thanks for introducing me. Thanks, Kavita.
Sorry for the
What?
inconvenience, ma'am. Sorry for the
Okay.
inconvenience. Okay, can.
Okay, I
You
will
can
start the session now. Yeah,
Yes.
I'll share the screen. PPT visible?
Yeah. Yes, ma'am. Yes, it's visible.
Yes. So thanks, Kavita ma'am, for giving me the session on EDA. So I understood that the theme of this series of lectures is on EDA, exploratory data analysis. And today's session is on understanding the role of machine learning in EDA and how it is helpful for EDA and for model selection. And this is the agenda for today. I'll start with ML fundamentals. I hope it is a heterogeneous crowd, and all will have at least basic knowledge about ML. So I will introduce some of the basic concepts and highlighting some of the techniques. And then I'll move on to what is the drawback available in traditional EDA and how can be resolved, or if there is a paradigm shift possible with ML as an enhancement layer added to EDA. And in this supercharged EDA, let us discuss how the ML techniques are very helpful in EDA process. And I'll discuss some of the auto EDA library tools, and followed by some success stories or case studies on ML enhanced exploratory data analysis. So first, it's a very primitive slide. Of course, hope you all know the whole world is buzzword is right now AI. Everywhere AI and ML is a concept. Even the layman, any level of people know about this, at least at the high level. And being a professional research community, we are all have to get to have a good idea about this. So you all know AI is a computer system, or it's a theory and development that will perform the task mimicking the human being, human intelligence, start with perceiving, classifying, learning, and reasoning and acting. So there are very many components involved in AI. In that, the learning is a very primary component. So that is only the ML component. So machine learning is a subset. It's a branch of AI. Here, it will deal with design and development of algorithms, right, or the models for learning process that will enable the computers to behave like a human based on the empirical data. Of course, here it doesn't involve any reasoning component, but at least it will learn actually. So it uses a mathematical model or algorithm to recognize the patterns based on the data given by analyzing the data, and it will predict the outcomes. And of course, it will be helpful for us to take intelligent decisions, right? And whenever we say learning, it will learn from experience based on the given data for a particular task, right? So we cannot have a machine learning model learned for a multiple task at a time. That is a future of ML, a feature of AI even. But now whatever the ML we talk about is it is getting learned for some specific task, okay, and for a particular performance measure, and it will keep on improving the experience also by focusing towards a particular task, looking for appropriate performance. And when you consider the traditional programming versus machine learning, you just have a look of this. In traditional programming, we all know we give the data along with the program. The program will have the task to be performed. Along with that, we'll provide the data. So on top of the data, the program will be executed, the output will be obtained. But in the case of ML, machine learning, here we provide what is the output we want, right? Along with the data, that we call it as a training data. So the training examples or data will be in the form of the set of data along with the labels that we call it as an output. So for that, the system will understand, it will generalize the data, it will come up with a model, right, with the help of a program. So we call it as the output is a program or a model which has been learned for the given data and generalizes the data. That means that it learns. How we learn from the childhood, we have been learning many things. Same way that we are giving lot of data to ML system, it will get learned. So here, if you see, it involves, you all know that training part and prediction stage. In training stage, as we all know, so here the label along with the input will be given to the system. And from this, the appropriate stages will be happening. Important one is feature extraction. It will extract the features and it will build a model with the help of appropriate ML algorithm. And at the testing stage, when any one input is given, here it is set of input along with the labels. Here any one input is given, the corresponding label will be classified or predicted. Same way, it will do the feature extraction and it will make use of the model already have been learned by the system. It will provide the label. So this is a general machine learning workflow. I think hope you all know that. And when you see the broader AI learning models, I think we have heard about these two terms, inductive learning, deductive learning, right? So they are based on some knowledge, means that if it is inductive, we provide the data to the system, it will derive the rules, right? With the help of which it will get learned. Whereas in deductive learning, it starts with the rules and it will infer a new rule from the top of it. For example, if you provide the data and if you are expecting the system to classify it into a spam mail or not, right? Based on the data, it will keep on learning. That is inductive learning. Whereas in deductive learning, we provide the data because we know that if the mail has got some suspicious activities, these many number of times, these many suspicious things, it can be categorized as spam. So like that, it starts with the rule, whereas inductive starts from the data. And one more thing, you all know, these are the major categories of learning: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. So it is the self-explanatory term. Supervised learning, in the sense it learns from the labeled data. So whatever the data given for the training, they are having the label, and we call it as the data with external feedback. And under that only we have mechanism, classification, regression, prediction, all those. So the system has been supervised or supplemented or being guided with the labels provided. If it is unsupervised learning, only the data is unlabeled. It's unlabeled data. So the system has to explore the data, analyze the data, and then it has to come up with a pattern. Okay, so it is a pattern, finding the pattern without any external feedback. Here only we have clustering, probability estimation, association, dimensionality reduction. So here the set of data along with the labels will be provided for supervised. Here the labels, unlabeled data is given. In semi-supervised, it's a middle ground between these two. It makes use of small amount of labeled data and large amount of unlabeled data, of course, to infer the new label. And in the case of reinforcement learning, I'll touch upon these two in a little bit detail in the later slides. In reinforcement learning, you all know that it learns by interacting with the environment through rewards and punishments. So here, especially robots and game playing environment, this reinforcement learning is majorly called upon. So here the AI agent, the learning agent will explore the action in such a way that it will maximize the rewards. And this is one visual illustration of various types of learning. If you observe this supervised learning, you could observe the labels are, data are labeled. In the sense, this kind of green colored ones are star, and these are plus, and these are circles. So these are the labeled data given for training. Whereas here, no labeling, all are asserted data. We don't know what is what, right? So this the system has to explore and find out. So this is unsupervised. Whereas in semi-supervised, it has got small labeled data and lot of unlabeled. So you could observe some stars, some plus, some circles are there. Apart from that, there are very many point space data points which are not having labels. So this is called semi-supervised learning. And if you see the overall taxonomy of the ML, right? Just now, as I have introduced, supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. Under supervised, we have regression and classification. And under classification only, we have decision trees, random forest, artificial neural network, deep learning, Bayesian network, support vector mission, k nearest neighbor. These are the various techniques under classification. Under clustering, we have k-means, hierarchical clustering, fuzzy c-means, all those things. And of course, under semi-supervised, and under unsupervised, we have another one called dimensionality reduction. So here, singular value decomposition, principal component analysis, ICA, all those things. In reinforcement learning, of course, Q learning will be there. 1 second. So Q learning. So these are the major coverage of various learning techniques. And if you see the learning process, the input, for example, it may be any environment. Either you give the input directly, archived data, or you have an environment, can be an IoT environment, anywhere the sensors, various sensors are there, or measuring devices are there. They keep on providing the data. Whatever it is, it has to be pre-processed, and appropriate features are to be selected. Then model has to be learnt, and for that the model testing will be done on top of the learnt model. So the learnt model, as you all know, whenever we say the system is getting learnt, the learnt model either in the form of a rule form or a tree form, decision tree, or it may be a statistical model, or it may be a formula, right? This is a way, because any human being, we learn something. Everything is registered in our brain in the form of if then else rules. See, always, if you encounter any chair or a table, so you see the shape of the chair, right? Color and texture, then you say it is a chair, right? If it is stable, this is a kind of shape, and this is a kind of other features, characteristics. So we check with our system registered in our brain, which is of the form. If these features are tallied, then it would be this, right? So like that, the learned model can be basically rule form, or it can be in a different formats like tree form or statistical models or any formula based also, right? And when you come for testing that, and whatever the model you have developed, how good it is to test it, or when you do the learning also, it has to take the training data. It has to take the entire set into training and testing data. By the time only we have cross validation methods or bootstrap techniques. So that and all I'll cover later a little bit. So if it is cross validation, you divide the data in such a way that 70-80 or 70-30 or 80-20 training data, testing data, and you cross validate it. Under that only we have k-fold. That means that if it is k is equal to 10, so it will 10-fold data will be, it is divided into n number of folds, and it will be checked for the testing part. And bootstrap, in the sense, it is a samples will be taken. It is a resampling technique. So it may be with replacement or without replacement. The samples are considered for learning. And if you see the supervised learning, little bit more detail. As I earlier said, it uses labeled data. Okay. So what it is building is a model, which is, we call it as a predictive model. Just because later on when any one input is given, it has to predict the label, what it is, what class it belongs to, right? So here labeled training data. And here you could observe this diagram. So training data can be in the form of text, document, image, or sound, whatever it is, along with labels. So the features are extracted, given to the algorithm. Any one input is given, the same features are extracted, it makes use of the model built, and it will say what it is, expected label. So under this only we have decision tree, support vector mission, and maximum entropy, all those stuff. And under many other techniques like we have eager learning, because you all know there are two types of learning under supervised learning. Eager learning, lazy learning. That means that the word itself gives a meaning. Eager, lazy. So eager in the sense, whenever a training data is given to it, it will learn from that, it will generalize the data, and it will build the model. So the model is ready, eagerly waiting for any test input to be given. When any test input is given, immediately it starts understanding, because based on the constructed model, earlier constructed model. Under that only we have decision tree, algorithm, neural network, naive-Bayes classifier, support vector, missions, all this rule induction algorithm. So they are all coming under eager learning. So the on giving the data, the model will be built. Immediately the model will be used for testing. But in the case of lazy learning, it on seeing the data, it won't construct the model, right? Only when any test input, the data is given, test input is given, it starts building the model, with the help of which it will try to understand. Under that only k nearest neighbor. So you all know in k nearest neighbor, it is looking for k number of nearest neighbor point to take a decision on a particular data point which it wants to predict the label. So after giving the test input, it looks around, right? It looks for the training data and trying to understand what it is. So that we call it as instance-based learning. And one more learning methodology is ensemble learning. I think, I hope you all know. It's a collection of learning models. Classifiers will be together used for decision making. So under that only we have a random forest, right? And bagging model, boosting classifier. So whereas n number of classifiers are together collectively giving the label, deciding the label. Okay. And for example, in supervised learning, I have given some examples here. So if it is disease diagnosis, right, its input will be the properties of the patient, like symptoms, lab test, whatever you give. It will say it is there or not, right? And if it is POS tagging, part of speech tagging, if you are providing a document, text document in whatever language, English sentence, it has to understand what is the POS, part of speech. So the part of speech individual stuff can be treated as a label. It will simply label the words. And if it is image, face recognition, input is a bitmap picture of a person's face. It has to say who he is, what is the name of the person. So like that, depends whatever may be the input. Here it is maybe a lab test or X-ray or whatever it is. POS, it is English statement document. Here it is face image. Even in autonomous driving or automatic steering, the road, whatever the in front, if it is autonomous car, in front of the car, whatever the road image, no, the picture of the road surface will be captured lively, and it has to, on the spot in real time, it has to understand the road scenario. Accordingly, it has to drive. Drive in the sense, it has to turn the steering wheel. So here it is capturing the input as a road surface in the form of a video. It analyzes and it does. So everywhere, based on the training data, it understands, accordingly it acts for the test input. So in unsupervised learning, as you all know, here unlabeled data. So you could see that only the training text, document, image, sounds, without labels it is given. Features are explored, right? So then with the help of whatever the unsupervised algorithm, it will build a model. Then input is given, it will say what it is. So here we call it as, it is for example, major learning mechanism here unsupervised is clustering. Clustering in the sense grouping the similar instance together, right? Whenever it is grouping the similar instance together, whenever you have assorted objects, it will try to group the things, objects in such a way that it will minimize the intra-class distance, maximize the inter-cluster distance. That means that intra-cluster in the sense, within one cluster, all the points, the distance should be very, very less. That means that they should be closely packed. Between the clusters, that is inter-cluster, it should be well separated, well far away apart. Then only we can say it is a good clustering. So raw input is given in the form of assorted. It is able to make a groups in such a way that well distinguished groups can be separated. So it has to fulfill this criteria for any good clustering mechanism. So examples, for example, community identification in the internet, right? Even customer segmentation. So all those things for clustering, that is a grouping the data points. So here it is trying to find the underlying patterns in the data, and we call it as learning without a teacher. That means that here only data is given without labels. So it is learning on its own. Under unsupervised learning, we have K means clustering, hierarchical, spectral, all those things. And we have one more unsupervised learning, because the clustering is very predominantly famous everywhere in unsupervised learning. Equivalently, we have dimensionality reduction is also unsupervised learning. Density estimation. Under that, we have Gaussian mixture model, graphical models. Under dimensionality reduction, principal component analysis, factor analysis, SOM, self-organizing map. Because here I have prepared a PPT and presenting in such a way that simply highlighting the different learning mechanism, what are the categories available. So if I start talking on entire mechanism techniques, it will take the whole session. Actually, how to bridge with EDA. So I'm giving the umbrella terms, right? And this is semi-supervised learning. You see this diagram. We have small labeled data and lot of unlabeled data. Okay, so the training data includes only few desired output. That means that labeling is only for few. And in which scenario this supervised, semi-supervised learning is required? Wherever the labeling is very expensive and it is difficult. For example, you all know that in at the time of COVID, we started the research on COVID. That time we could not get any labeled data set for COVID, maybe very limited data, because it's very difficult for the medical doctors or medical domain labeling all data. No, it is very expensive or time consuming, right? So by the time we have to use semi-supervised learning. So the labeling sometimes, it is unreliable. So need for multiple experts, right? So by the time, unlabeled data getting is very easy actually. Even if you take some web pages and all, they're all plenty available, but it is requiring a lot of labeling, which is very expensive. By the time we rely on semi-supervised learning mechanism. And the last one is reinforcement learning. So you all know that this is a kind of agent will be interacting with the environment, and based on the action it takes, it gets a feedback, right? Whatever feedback it is obtaining, it is learning its behavior. So it learns a behavior based on the feedback. So the behavior learning, it can be once for all, or it keep on going, it keep on learning also. Whatever the learning it makes in such a way that it does best actions that will maximize the long-term reward, right? And here we can say that how can an agent can learn without a teacher? How it will do? First, it will do some task, right? If it wants to do some tasks, it will perform some actions and it will get back the feedback. Based on the feedback, it will do the appropriate task. For example, if it does correctly, it would have got some rewards. So it knows that those actions which can be repeated well. Suppose if it does wrongly, automatically it gets punishment. So automatically it understands that should not be repeated. So this we call it as reinforcement, getting feedback. So it can be a positive reinforcement or negative, right? So it gets positive reinforcement for the task which are done well in a correct manner, and it gives a negative reinforcement for the task done poorly. Okay? So in that way, it interacts with the environment. It gets a reward back based on which it does the action based on the observation. Ultimately, the goal is to get the agent to act very smart so as to maximize the reward, minimizing the punishment. So if it is doing like that, no, maximizing the reward, it is learning better. And you all know that this is a very good scenario which is expected for any robots to learn. So you all know that for robots, we cannot make all data to learn everything on its own entirely like human being. Sometimes it has to act very smart, equivalent to the human, sometimes more than human. So by the time the reinforcement learning is only used. So out of all learning mechanism, reinforcement learning is a complex one. Okay, just to introduce the basics of ML, and I have introduced 4 different learning mechanism: supervised, unsupervised, semi-supervised, and reinforcement. Now, having built a model, how to evaluate the performance of a model? So you all know the formula. I think you're all familiar with the precision, recall, F-score formula. So precision is showing the exactness. Whatever the model you have built, classifier, the model you have built, how good it is, how exact. What percentage of tuples classifier say it is positive is actually positive. Okay, that is exactness. So true positive by true positive plus false positive. And recall is the one which says about the completeness, meaning what percentage of positive did the classifier label as positive. Okay, so this is true positive by true positive plus false negative. And ideally speaking, the value expected is 1. Towards 1, if you get to have value, it is a good performance. Okay, towards 0, it is performing very bad. And F1 score is a combined measure of precision and recall, 2 into PR divided by P plus R. Apart from that, you have 2 more metrics: sensitivity, specificity. And generally, whenever you have a class imbalance problem, for example, one example given is HIV positive, right? So if it is AIDS, getting the HIV positive test sample is very, very difficult, but HIV negative will be more and more. Then how do you make your system to understand by giving very less number of HIV positive, but more number of HIV negative? So the system cannot generalize the samples, So by the time one class is more in number, more data, training data, for the other class, very less number. So this we call it as a problem called class imbalance. One class may be very rare. So by the time, how do you ensure the performance of your system? So there we use sensitivity and specificity. So here we call it as a true positive regression. Out of so many positive, how many are correctly identified as true positive? How many out of total negative, how many are correctly classified? Because if you combine both, it may give a wrong picture if you have a class imbalance problem. And of course, accuracy is this formula: true positive, true negative by all. Out of all, how many samples are accurately classified? 1 minus accuracy is error. And here, whatever I have given, true positive, false positive. If it is true positive, that means that the model predicts it is a win, positive, and the team, the actual and predicted are same, true positive. But if it is false positive, whatever the model you have built, that says that it is positive, but actually that is a negative. So something like that. So false negative, true negative. Okay, having understood basics of ML and mechanism and how to evaluate, let us move on to the connecting the dots between EDA and ML. Okay, you just have a look of this right side. This is a machine learning life cycle. Starts with problem definition for a given problem. You collect the data, clean the data, pre-process, then you give it to EDA, exploratory data analysis, right? Followed by feature engineering and selection. Then suitable models are selected. Then model is trained, right? And evaluated, model is deployed. This is only entire ML. In that one stage is EDA, exploratory data analysis. So this is the foundation for modeling. And of course, one more thing, it is not a one-step process, it is an iterative process. And of course, it improves the modeling performance also. And when you same thing is given here, raw data collected, data is processed, clean data set is provided to exploratory data analysis. They are better analyzed and visualized. It will better understand about the data, relationship among the data, right? It will analyze the hidden patterns. Then the suitable models are picked up, selected, and the system will get learned or will be analyzed better, right? This is so it will be helpful for making the decisions. So this is a place EDA is there inside the ML life cycle. And when you see the exploratory data analysis stages involved, as I said earlier, problem definition, understanding, data preparation and exploration. There only we have exploratory data analysis. Having even a raw data, it will give the very enriched good data understanding data in the form of visualization also, followed by modeling, evaluation, deployment. So this is only EDA stages where it is the entire flow. And what it does actually, how EDA, what it does, what it is working. So entirely here, it will transform your raw input into a comprehensible graphs or trend identification or pattern identification, all those stuff. I think in the earlier session, you might have listened to this EDA, how it is working, what all the things are happening, exploratory analysis, univariate, multivariate, correlation analysis. So that it will be exposing, it will be finding the trends, okay, in the form of plots, line charts, something like that. And it will differentiate, it will analyze the data and it will show the difference between the data in the form of box plot. Okay. And it will try to get to know the correlation among the data and visualize it, scatter plot. So like that, all those EDA things are happening. You all know because directly landing upon the analytics model, before that, this EDA has to be performed just to get to know the trends or differences or correlations. And what is the problem with the traditional EDA? Why do we need ML here in the EDA analysis? The the entire problem is the data set is very vast, very huge, high dimensional data. It's very complex data. And if you perform any manual analysis, manual EDA, it is a time consuming, and because the humans are involved, the human bias will be there, right? And there's an inconsistency also. One person analyzing the other person, there will be a difference, and superficial insights are also possible. So the question to be addressed is here, how to make this EDA even more faster, deeper, more consistent, and more comprehensive. Because if you all know that the data pre-processing may be not a main task, but if the data is not properly pre-processed, the entire later mechanism, even though they are very efficient, may not be helpful. So this is a very crucial area where we have to concentrate better. So the time consuming in the sense, for example, if you take data cleaning and filling the missing data, imputation and profiling the data, that is only consuming the entire 60 to 80% of the project time. So that's why deploying the ML for this EDA to automate the process instead of a manual thing is the required one, need of the hour. So machine learning, that's why the machine learning purpose is very much required in EDA. If you observe the traditional EDA that uses a descriptive statistics, you might have seen a number of sessions earlier, and all those visualization and correlation analysis, distribution, all those are formula based, But if ML is applied here, it will become ML enhanced EDA by providing, by having all those mechanisms in terms of unsupervised learning, especially clustering and dimensionality detection, anomaly detection, feature extraction, structure discovery. So if these ML techniques are adapted for EDA, okay, it will provide a better insight, deeper automated insight that cannot be easily obtained manually. So that is the ultimate area why we are going for ML in EDA. So ML enhanced EDA. So that we call it as ML as an EDA enhancement layer. So it will not only replace EDA, normal EDA, it is augmenting it. So given one analogy here, the traditional EDA, whatever exploratory data analysis performed so far, it is like a microscope. Simply you see that whatever the object in front of you using the microscope, and the interpretation you have to do manually. But if it is ML enhanced EDA, it is like advanced lenses that has autofocus and AI powered image recognition. Okay, it automatically find all those patterns, right? Whenever you analyze the data. So because of which we get to have the following benefits. It will automate the TDS, right? So the repetitive task can be better done automatically, and it eliminates a hidden pattern. It will cover the complex patterns, and it will empower the analyst also. So what it will do? So the ML in EDA, right, exploratory data analysis, it will uncover the hidden patterns because of the use of very many mechanisms like the clustering and all. Automatically it will explore the data, it will find out the complex patterns. And analysis quality is also improved, and automatically, it is automating the task. And it is helpful for model development also, right? We will talk about model selection, choosing the right algorithm later, and for hyperparameter tuning also, right? We can better, when you're building a model, the hyperparameters which are to be optimized to get to have a good, very good model. So that and all, very helpful here by using this. And these are the ML techniques used in EDA. So if you see unsupervised learning, K-means, DB scan, hierarchical clustering, they are used to group the data in EDA. Wherever in exploratory data analysis, you want to have an understanding of the data, right? How similar they are, something like that. It can be grouped. And to reduce the dimensions, right? And visualize. We have principal component analysis, TS, SNE, UMAP, all those things. And if you want to identify the outliers or anomaly, then isolation forest, all those things are there, auto encoder. And if you want to find the frequent patterns or association among the things, or to find out the co-occurrence of the features in your data, association rule mining can be called upon. And here, like that, to know the feature importance, that is very, very important one, because a lot of features are there. What are the features which are significant or which are powerful, right? To identify that, feature importance can be performed with the help of random forest, XGBoost, all those machine learning algorithms. And we have a lot of automated EDA tools. I will tell all those things later in the next few slides. When you see the whole entire process, here the raw data is cleaning is done. Normal statistical analysis, exploratory data analysis can also be performed, followed by ML-based EDA. It will improve the strength of the EDA so that the insights will be obtained about the entire data in detail. Then the feature engineering can be done, followed by the model selection, okay, before we train the model. And first ML technique here, how ML is helpful for EDA in automated data preparation. So you all know that whenever you have a data set like this, if some of the points are not having data, so missing values are there. So far in traditional EDA, they'll fill the value with the help of mean value, median mode, right? So it will entirely distort the original distribution of the data. You all know, if I fill the data, suppose I have 60, 80, 100, 120, and all of a sudden I have 50,000. And one more data is missing. So if I take average of all data, mean, that value will be totally different because one data is outlier, 50,000. Okay, so the mean, if you are taking a mean and replacing it with filling the missing data, it will spoil the entire distribution of data. But in the case of ML enhancement, K nearest neighbors are used so that it will look around the particular point where the data is missed, like this. Then based on the neighbors, it will take the most similar one to the missing one. Then it will impute the value. This is called imputation. Imputation is filling the unknown missing value. So it will fill the data based on the neighbors. So it's a kind of unsupervised learning mechanism. So not unsupervised, it's supervised learning, but it is a lazy learning method. So this is called KNN imputation. So in this way, ML is used here in EDA. Because in exploratory data analysis, one main task is data preparation. So here it is automatically done. Rather than filling the data blindly with mean, here it has a logic strategy. Similarly, if you want to find the outlier deduction, so outliers generally, in traditional EDA, they do it with Z score or interquartile range and all, right? So if you have a high dimensional data, this will not work good. So they go for ML based mechanism, isolation forest. So you could observe here in right side the diagram, isolation forest. So if these are the points, if the outlier, it's explicitly not complying with the other data object. So it is only few in number, but they are different. So that is easier to isolate. Whereas here it's normal points, they are regular data points which are difficult to isolate. So it can be done with the help of isolation forest mechanism. So that it will find the outliers by building the n number of random trees and finding the outliers. It is done faster. And the second exploratory data analysis, advanced pattern discovery. Let us see how ML is supplementing this. So here unsupervised learning mechanisms are used because we all know k-means or a DB scan, they are the clustering mechanism. It will simply find out the natural groupings, right? It will segment the data without any predefined label because it's unsupervised learning. So in the case of EDA, if you want to segment the customers, right, or any anomaly has to be detected, so these kind of clustering mechanisms can be used to find the outlier deduction or customer segmentation. These are called advanced pattern discovery. Even hypothesis generation also. So from the clusters formulated, it will have a next level of understanding rules. Why are these specific customers clustered together? What defines this group, right? That hypothesis also can be well generated. So you may have a question, what is the need for hypothesis here? Having grouped the data, for example, if I have a customer database, I'm grouping it into 4 clusters. I don't know what each cluster means, right? So the one cluster, maybe the cluster of having, they are based in some location in a group, a closed manner. Maybe they are in T Nagar or they are in some other place. That's why they are grouped together. And based on that, the targeted marketing can happen. So this is the purpose of hypothesis generation. And one more thing is to find the relationship between the data, right? The traditional mechanism, generally we go for correlation analysis, but it will miss out the complex relationship. For example, the particular feature is only important when the other feature is high. This kind of relationships are not obtained with the help of normal correlation matrix. So if you adapt some ML mechanism like decision trees or random forest, it will try to learn a series of rules and capturing the complex interactions. Okay. So very hidden interaction effects or conditional dependencies can be well captured. If it is decision tree, here only one model, one prediction. If it is random forest, it is forest. There's a group of decision trees and average of the predictions can be the final output. So with the help of which it is better to understand the relationship between the data. So that we call it as advanced pattern discovery. And the third mechanism is intelligent simplification and focus. This is the one required for EDA. Now let us see how ML is supplementing this. Some simplification in the sense dimensionality reduction, reducing the size of the data. Because with so much of hundreds or thousands of features, it's very difficult to visualize the entire global structure. So instead, if you apply the dimensionality reduction method, principal component analysis or a TSNE. So all those are machine learning mechanism. So, and one more thing here, it will reduce the data in such a way that they'll project the high dimensional data into project it onto a 2D or 3D plane without losing the structure. That is a highlight here. It will not collapse the data. It will preserve the structural information. At the same time, it is reducing the data. So that is the beauty behind ML algorithm here. And the other one is feature importance, as I said, right? Having got n number of features, 100 plus features, what are the important one which will be helpful for later processing? So here, the tree-based models can be used so that we'll get to know the, for example, random forest, XGBoost can be used. It will give the scores for every feature. So based on this feature score, it will understand the importance of the features. It can be hierarchically arranged like this. And you can have a cut here. How many features you want, you can retain the top 3 or top 10, something like that. So far I have given some of the ML techniques which are very much helpful for EDA. Now auto EDA tools. For example, popular tools, Y data, right? Y data profiling, pandas profiling. It's a very standard tool to see the data overview, and suite visualizing the data, right? And then AutoVis. This is a wide array of visualization will be automatically generated, with the help of which actually what they are doing inside is that they do the data type inferencing, right? And it will do the univariate, bivariate analysis. So all those things are performed and it will visualize the data. So it's ultimately data profiling is done. So what kind of data, what properties are there, what kind of relationship and visualization, everything, whatever the manually so far traditionally done, here it is automated. And these are the ML powered EDA tools comparison. The same thing I have given: Y data, SuiteVis, AutoVis, Flex. And primary, what actually ML is happening here? It is automated data quality and providing the insights. Here it will do the comparative ML analysis. It will compare the data distribution, and whatever the drift or change between the data set, it will be announced in the visualized form. Like that, there are various tools are available, and even some more: data prep, pandas profiling, detail, evidently AI, right? So all those things. So here, of course, even interactive ML exploration is there, right? So whatever it provides, you can interact with it, you can get to have the better results. So all those things are there. And now, as I said earlier, the ML capabilities are only strengthening our EDA. So if you already have given, these are the types of tools that makes use of ML to enhance exploratory data analysis. So here what it does, just now I have covered some of the topics, right? So the automated pattern recognition. So in these tools, it will find the correlation of data, it will group the data, right? It will find the relationship of the data without any manual intervention. It is automated fully. And even intelligent visualization selection also, right? So, for some of the data characteristics, we may not know which visualization may be better, right? So it will recommend the optimal chart type through which you can visualize the data. It will understand your user intention. Accordingly, it will recommend or suggest which data chart type can be better used to visualize and understand your data. And obviously, anomaly detection is a very crucial one, because in your data distribution, which is the outlier, which is the unusual pattern, detection is a very, very important one. Sometimes the outliers may be even useful also, right? The fraud detection and all, the usual, rather than focusing on the usual behavior, focusing on the unusual behavior is very, very important. So they are automated here. And as I said, if you want to compare the statistical distribution data between two data set, we can do this and find out the drift between that. And if you want to know what are the features are very significant, right? You can make use of these tools. So everywhere the machine learning capabilities are involved to strengthen exploratory data analysis. And this is for one healthcare data. case study wherein they have the diabetes record, right? It's a high dimensional data. So finding the manual pattern discovery is very, very slow. So they make use of all those ML mechanisms.
I found this on the web for finding.
It makes use of all ML algorithms to uncover the hidden relationship. So what they have done inside is they have adapted the random forest just to know the feature importance. Because for a particular patient, the indicators, clinical indicators, BMI, glucose, and all those things are there. So what are the parameters which are to be given more importance to find out the diabetes, right? So for that, they have used random forest. And to know the correlation, right, they have used correlation mapping and ML based ranking, and then clustering they used to detect the risk levels grouping, right? Like that, they have applied very many ML mechanisms for healthcare data, and they get to have the pattern discovery. So here it's a correlation heat map, how diabetes is correlated with other variables, right? Anyway, we are not able to see the variables name here. There are very many clinical parameters. Just the correlation is being observed. This is for EDA, right? Exploratory data analysis. They want to have an understanding about all those variables describing your data. For that, they have used the ML algorithm. And here again, profiling. You could observe yellow color, violet color, and blue colored ones are the different clusters, right? And they are depicting the medical profiles. And the second area is retail, right? Retail sales forecasting. You all know in retail industry, the demand is to be observed, right? So the retail companies know they are struggling to understand the demand drivers. So for that, they will do the exploratory data analysis. And generally, the temporal parameters and all other parameters are being observed. So here they use the regressors, machine learning regressing methodology, regression, to build the predictive model. So in this paper, they have used the gradient boosting to identify the strongest sales predictors, right? As I said earlier, feature which are so important to predict the sales, which are observed, right? And then the clustering and sharp analysis. So all those things are done. And the visualization is shown here. So it measures the contribution of every feature to the model prediction. And this is the manufacturing industry where they detect the defects, right? This is an image. So this is a heat map visualization, normal image and abnormal image. Okay. So for that, generally, it's not, when you see it in a normal way, humanly manner, it's very difficult to find out. Here, anomaly indicates that this is an abnormal image, okay? Normal and abnormal. So for that, they have used the auto encoders to detect the unusual pixels, and which is that unusual pixels are not even can be captured in the manual inspection. Okay, and clustering is used after they point out the individual data points which are unusual, and they are being grouped with the help of clustering, and it will say the defect. So here it's abnormal things are grouped and indicated. And finance for fraud detection, right? And generally, the fraud data sets, as I said earlier, they are highly imbalanced in the sense the fraud labeled data will be minimal, rare, less, whereas the normal data will be more. So by the time the traditional EDA cannot get the good patterns. So here they have applied the PCA and anomaly detection method, and feature importance are being identified, right? With the help of which they better detect the frauds. So here they talk about the principal component analysis, dimensional reduction, and then finding the features which are important, then detecting the frauds. And even in environmental science, to judge the air quality, because there are very many pollutants, key pollutants, which will influence your air quality, right? So for that, here, when they do the exploratory data analysis, normal statistical analysis, they miss out a lot of parameters. Here they do the feature selection. Okay? important features which are influencing the air quality. Then they group it, grouping the similar weather pollutant patterns with the help of clustering. And then they use a regression mechanism to find where it is deviating, right? Then they judge the quality of the air quality. And so far, I have told you, I have indicated the case studies where how the machine learning mechanisms are improving the EDA results in very many sectors, environmental science or finance or manufacturing or sales, okay? Healthcare, something like that. So any area you take, there is a role of ML, obviously, which will enhance your exploratory data analysis. And we rightly understood this EDA is, of course, the first stage, preliminary stage before you go in for the actual model selection. You see this diagram, as I earlier said, business understanding, data understanding, then data preparation. Under data preparation only we have EDA, which will be followed by modeling, evaluation, deployment. And you may have a question, what is the connectivity between understanding data preparation and the model selection? And there are plenty of models available. Which models are to be chosen for the given task, right, is being judged by the analysis whatever you have made in EDA. So after the EDA is done, the model selection will be supplemented or guided by the problem type, whatever the task you want to perform, and nature and volume of the data. Apart from that, whatever the insight you gain from the EDA, there only you got to know what are all the outliers, what are the values are missing, what are the relationships are between the features. So based on all this understanding only, the model selection can be well performed. So that's why the EDA is in turn, it is very, very helpful to choose the appropriate model. You should understand one thing. So far we talked about, while you're doing the EDA, exploratory data analysis, like imputation or data preparation, how machine learning mechanisms were helpful. Okay, that is one flow. The other flow is EDA is performed before the model selection in your learning process, because the EDA gives lot of insights, helpful for choosing the models. So how this EDA helps in model selection? Okay, so as I just now we have seen, with the help of exploratory data analysis, it is possible to understand what is the data type and distribution data, because we all know it does a lot of analysis. It will get to know the type of features. The features can be continuous, discrete, ordinal, categorical. So whatever it is, it will try to have an understanding about the features, right? So that the appropriate model can be chosen. And the relationship between the features are also have been explored in EDA. So that will show the correlation or whatever the interaction, everything. So that will be helpful for model selection. And of course, missing values and identification of outliers, obviously that will guide the selection. And why it is necessary? Because whenever you have the missing data or outliers are detected, whatever the model you choose, that should be robust enough to take care of these data also. So if it is a very normal data, right, pakka data, building a model is not a big deal. But if you have a data with a missing value and outliers are mixed there, and coming up with a robust model, no, that is only very tricky job. So for that, EDA will be helpful. And whether it is a categorical or numerical mix, right, then accordingly it has to choose the algorithm, right? There are very many algorithms it will choose. Sometimes needing heavy pre-processing, whether the variables are requiring pre-processing or not. Accordingly, the SVM or logistic regression can be chosen, or the boosting algorithm can be chosen if it is categorical. Something like that. The model can be selected based on the EDA outcome. And some more. Because even if you do the exploratory data analysis, you can come up with the identification of class imbalance problem, as you all know. So the imbalance in the sense, the type of training data, whatever data you have, some are having a high number of labels for one class, less number of labels for the other class. And feature importance and variance, as I said, you could have gotten better idea what are the features which can be significant, will be helpful for further processing. And temporal sequential patterns are also can be better captured with EDA, through which I can choose the appropriate time hour models, ARIMA model or LSTM, or which model, ML or DL model I have to choose, that we can see. And about the distribution of target variable also. And interaction nonlinear effects, because whenever you have the interaction between the variables, sometimes it will be linear dependencies or nonlinear dependencies. So if dependencies between the data may be negative or positive. If I increase one value, the other value may increase. If I increase one value, the other value may decrease also. So I have to have a good understanding about the relationship or interaction effects of the data. Then only, if it is linear or non-linear, accordingly how to choose the appropriate model, right? For example, suggest whether non-linear model or polynomial features, which are the model I have to go for, that I can easily decide. And of course, based on the data size and sparsity, right? Parametric model or non-parametric model, memory efficient model, because it's very huge sized data, and that is also demanding more memory efficient models. So like that, the EDA is very much helpful in model selection in ML process. And as I said earlier, this is post EDA. EDA exploratory data analysis is done. Now we are talking about the model selection. Here, even though you started with the problem definition, you have done a data understanding and data preparation in EDA. Now we are revisiting the problem definition after getting the insights from EDA. So now we are finding out, we are confirming whether it is a regression problem or classification or clustering. And this I forgot to mention, the classification versus prediction problem. If it is classification, we are predicting the labels, whether it is class A or class B, something like that. If it is regression, it is predicting the value, right? Very good example. For example, if I give you the employee database, suppose salary information for a particular employee is given in the form of a tabular form, history, name, age, qualification, experience, and salary. And one more, like that, you have got 1,000 employee information. If one person's data is given, if you are asked to predict the salary of the person, salary column alone empty, then you are predicting the numerical value, right? That is only called regression or prediction. But in the case of classification, simply you are saying whether it is COVID positive or COVID negative, whether he is having AIDS positive, HIV positive or not, whether the cancer is malignant or benign. So those things are called classification. Regression is predicting the value. So clustering, as you all know, it's a grouping, right? Similar data points. So you are revisiting and confirming the task again based on EDA. Then you are analyzing the data characteristics, right? You are just understanding the size of the data, whether it is linear or non-linear, as I said earlier. Then identifying the outlier and noisy data present, so that it will be helpful to choose the robust model. And of course, feature importance and intercorrelation among the data. Those are the things which are to be analyzed before you choose the model. And of course, you have to understand the model complexity also. So underfitting versus overfitting. I hope you all know that overfitting, underfitting. For example, overfitting in the sense, it is doing nicely for the training data, right? If I keep 70% for training, 30% for testing, for the trained model, out of the training data, if I give the input, it is performing very good. But the remaining 30%, right, the testing, if I give the data and testing for the classification, it's not performing good. Then it is called overfitting. Okay, underfitting in the sense, it's not performing well for training data also, training as well as testing. So that shows that more training data to be given in underfitting, right? So like that, we have to find out the model complexity. If it is a complex data pattern, accordingly, you have to have a good model. And of course, next, after that, you have to try experiment with multiple models. If it is a regression, you have a lot of choice, right? See, I think I hope many are teachers here. And when you're teaching this subject, right, especially ML or similar to this analytics subject. For any given task, you have a lot of choices. Even classification, I have a lot of choices. Clustering, I have a lot of choices. The students may have, or you may have a question. Anyway, you want to do clustering or classification. Why do you have these many techniques? So each and every mechanism has got its own plus and minus. And you must know the appropriateness. Okay. For some scenario, this may be good. For some other scenario, this may be the good one. For example, if it is classification, support vector mission is a best two-class classifier. For the example which I stated earlier, like if you want to know the COVID positive or negative, benign or malignant, or something like that, either this or that, best classifier I can blindly rely on is support vector mission. It's a proven best two-class classifier, right? And suppose if I'm not very sure about the existence or probability of my results, right? Then I'm not very sure. Then you can go for probabilistic based classifier, right? Like that, you have to have an appropriateness. You have to identify the appropriateness of choosing the best model for the particular task. So that's why here experimenting with the multiple models and establishing the evaluation metrics. Of course, selecting the appropriate metric, right? And use cross validation or hyperparameter tuning. Because you all know once you attempt everything, you got the results. But then you are evaluating your model, then only you'll come to know how good, how well your model is generalizing the training data. If there is any gap, if there is any less performance, obviously how to fine tune your system. So that is only called hyperparameter tuning, okay, to optimize the performance. So I have done so many checks from the beginning, right? Initially with the basic problem definition, I started with the data preparation, exploratory data analysis. After EDA done, I'm revisiting my problem, making second check, and I'm analyzing all data analysis characteristic, choosing the best model, and considering the complexity also, I'm choosing the best model, and experimenting with multiple mechanisms under the particular model. Even though I have a lot of checks like this, if the performance of the system is not good enough, what I have to do, I have to fine tune the hyperparameters and I have to optimize the performance. So these are the real world applications of EDA. I think in the earlier sessions, you might have seen many EDA cases, right? So it's a dashboard, it's accounting software. Just visually, it is indicating the data distribution or characteristics of the data. So distribution of salary, so low, medium, high, and the total number of employees, average monthly hours spent, right? Number of projects completed, and employee promotion, how many are promoted, unpromoted, visually analyzing the data, visually illustrating. Attrition, retention versus attrition, how much. So these are all the things very much required, any business. And as I said earlier, any sector you take, either healthcare, finance, or retail, or education, everywhere, the exploratory data analysis play a role. That EDA performance can be even more enhanced with the help of machine learning. That is a takeaway today. For example, if it is education, what do you want to analyze, right? Exploratory data analysis. Just so you can analyze the student performance, attendance rates, and the engagement by exploring the relationship between how much hours they studied, what is the grade they have earned, right? So what supporting system required for students. So all those decision making to be done, to be taken, this EDA will be very much helpful. And this is one case study, combination of EDA and ML for Titanic, right? How many are survived? So they have done an exploratory data analytics to mine the various information, right? And they know the effect of each field. They have got n number of attributes or features, and they are simply predicting or they understanding the effect of each field on the survival of the passengers. You know about Titanic, right? Ship, right? So where the passenger survival, they have done an analysis, effect analysis. So by applying the analytics between every field of the data set with the survival field. So they have applied a lot of analytics like this: descriptive data analytics, exploratory, confirmative, and predictive. So they have analyzed the understanding the variables, significant variables, and they have done the correlation analysis with the help of ML, right? And they have done the fitting, goodness of fit test they have done, and finally they have come up with the final model implying that even the person is young age, the survival rate is good enough. Something like that they have come up with the decisions, strategic decisions. I think I removed all those graphs. This is one paper publication, published paper deals with Titanic ship survival rate of the passengers prediction with the help of EDA with ML techniques. And like that, there are very many case studies. I could not spare every slide with one case study. So I have summarized here. So as I earlier said, in banking sector, if you want to group the customer segmentation, traditional EDA, what they do, simply they look for the demographic information and grouped it. They haven't looked into the behavioral pattern. But if it is ML enhanced approach, they do the clustering with the feature importance analysis with the help of PCA, K-means, random forest. So that it is better results they got. And as I said, the manufacturing division, quality control, right? So rather than manually inspecting it, it's a real-time anomaly detection. So with the help of isolation forest. And even now, in the healthcare domain, the patient readmission, right? Generally, the linear models, whatever they have used earlier in EDA, they have missed the interaction effects. Okay, they have got lot of variables. They could not analyze the effect of one variable on the other. Whereas in ML enhanced mechanism, we call it as feature interaction analysis, so that the model can be well interpreted. So they can simply predict how many patients will be readmitted in the same hospital. Okay. And as I said, fraud detection, looking for the outliers or anomaly detection. Earlier, in traditional EDA, they have got lot of rules saying that if this is like this, maybe an outlier or a fraud. So it is rule-based system, and sometimes it goes wrong. Sometimes it's not covering the facts, right? Whereas in ML enhanced mechanism, that does the same anomaly detection, but with a behavioral clustering. I mean, even in supply chain optimization, what were the already normal static models used in EDA, it could not be done for the real time. Okay, so they have to do a lot of manual intervention. But here it is a route pattern clustering with predictive delay modeling. So supply chain, in the sense, if some products which are to be delivered, through various routes, so it can analyze the route pattern clustering, and it could have been better analyzed with the data and identify the delay, predicting the delay. Accordingly, it will analyze and find the route, right? So it involves time series analysis and clustering. So like that, all EDA involving ML enhance the outcome in various parameters. Coming to the last slide, I think I am well ahead. So we understood we have moved from machine learning, then deep learning, right? We are well ahead in that. But EDA analysis, so far it was statistically approached, okay? But now the entire scenario is drifting to a new phase, dimension, where ML is transforming the traditional EDA into a more automated, intelligent, of course, insight driven process. Okay. Of course, we know exploratory data analysis is nothing but you want to explore the data well, and you give the result in the form of visualized pattern that can be better automated with the help of ML. That is the ultimate takeaway. And the future is fully agentic AI, you all know, right? Even the automated EDA with AI agents is a current future trend. And intelligent data cleaning and pre-processing. That is, I think you all know about transformer model, right? Deep learning models. So that can be done. And feature engineering automation. For example, the new features which are to be derived in the, I think you all know about DL, ML versus DL. Anyway, I'll touch upon, I haven't covered earlier because the title is only ML. I haven't included a slide, but all of you must know that whenever it is the ML, no, for any particular task, domain specific features which are to be identified and extracted, even though it is an automated one. For example, if you develop for one particular disease, one system, right, that cannot be adapted for the other system, other disease model, then obviously the researcher should identify the suitable features to extract. But if it involves a big data scope, right now everywhere it is big data, so the fuzziness is also very much involved. Data fuzziness, feature fuzziness. So I cannot be damn sure whether I can take this feature or that feature to better demonstrate your data, right? So when I'm not very sure about the data, features are to be extracted from the data, we cannot make use of ML because a large data set and the fuzziness is also there. So that's the reason we all have moved from ML to DL, right? In DL, you have got lot of data to handle, but inside the data, the variedness is more, like the data structure and distribution or formats, everything is different. So it's very difficult to come up with common features. So we go for deep learning, right? So the feature engineering automations, even generative AI model can be used to come up with the new features. And natural language driven EDA, you all know nowadays everything is interactive, right? Rather than providing what to say, the detailed thing, you can voice out, you can speak, you can get back the reply in speech also. That is a natural language driven EDA. And personalized EDA, right? It's not only giving the normal common results for everyone. Based on the user behavior, it can vary. Personalized EDA and explainable AI for EDA. There are very many places it is giving some results we have to accept. We don't know for what reason it has come up like this. So explainable AI, and obviously integration of big data and cloud. Graph ML, right? The knowledge graphs incorporation for EDA. And one more thing, domain specific EDA model for various domains, healthcare, finance, something like that. The domain specific EDA model is the current trend. And auto model selection during EDA. So I have given you so many factors which are to be analyzed to choose the model, right? So that is also auto model selection is a future. So on the whole, we can say future exploratory data analysis, how it should be, how it could be. It will be fully automated, adaptive, real time, of course, intelligent, and conversational, right? Always we say conversational AI, the same way conversational EDA and explainable EDA, right? So an agentic AI based EDA. So this is the feature of EDA. And of course, we have moved on from normal traditional EDA to the ML driven EDA. This is the next step. Thank you. That's all from my side.
Participants, any questions?
One question is in the chat.
Chat, yes, ma'am.
What is that? Can you give me a problem statement for electronics domain for which we can apply data analysis and modeling? Yeah, of course, in our electronics domain also there are very many frequency modeling and selection. I'm not very sure about the electronics terms, but where you want to make a decision making, you want to classify, where you want to group your data points, something like that. Your data space environment, I'm not very sure in electronics domain. But if you assume any network, what is that? Network design also. Nowadays, the network designing also the machine learning can be used, because automatically it can design. For that, the system has to get learned. For that, you have to pass the system is n number of networks for a given. I think you are building a many electronics circuits and all, right? So the drawing the circuits on its own. So for that time, you have to make your system to understand first n number of circuits before in hand. The system will learn from top of it. Then it will build a common model. Thereafter, if you're asking the system to build a circuit for a given statement, it will automatically build a circuit. So this is one problem statement for electronics domain, where we can have the ML model, where of course the data analysis, of course to build the circuit, you have to pass on lot of variables, right? So all those variables analysis can be better done with EDA. And just now I have introduced EDA, we can make use of ML. So everything can be fully automated. So EDA can be performed followed by ML models. So it can better understand. I think I have answered the question.
Yes. Asha, she only writes the question.
Ma'am, good evening, ma'am.
Yeah. Good evening.
Ma'am, for two class classifier, you said that subvector machine is better than the other techniques.
Yeah.
Suppose if I am going to done a multi-class, then which one is the better, ma'am?
Yeah, that's what we have. A lot of choices are there, because, for example, a neural network classifier. The problem is that neural network classifier is a very good classifier for multi-class, but it requires lot of training time. I remember a few years back when we started neural network training. I think or 10 years before. We give the training data to the system. We won't switch off the system. Next day we come. The training took that much time, right? Because a lot of data. Yeah, it requires a lot of training data. So if you have the tolerance for training, more training time, but it will do very pakka testing. So the classification accuracy is very good enough. That's why based on neural network approach, we have got a new deep learning approach came into picture right now. So we can rely on a neural network for a very good multi-class classifier. But the problem or compromise is that it takes a lot of training time. Like that, we have k-nearest classifier. There are very many case-based reasoning method, and though everyone has got its own appropriateness.
Okay, ma'am. Actually, in recent papers, I checked that they used a Vision transformer for classification of the diseases. Whether we can follow the same?
Yeah, that is a deep learning model. See, that's why I'm telling, whenever we study ML for one particular, if it is a particular disease data, the researcher has to analyze and find out what are the features can be extracted, right?
Okay.
But whereas in the case of deep learning, our task is very much minimized. We are simply passing the data set to the neural network or deep learning. It is understanding on its own. So feature engineering is automatically done. Okay, so automatically it is extracting the features and doing. So the vision transformer is one such kind.
Okay, ma'am.
Yeah.
Okay, thank you, ma'am. Thank you.
And one question is, how do you decide which features to prioritize in EDA when you know they'll be fed into machine learning model later? So that's why I have told you features importance. Feature selection mechanisms are there. So wherein the n number of feature, for example, you have 150 features. You can give it to the feature selection mechanism. We have a wrapper method and filter method. So either you can choose any one. So it will come out with the significant features which are very much required for later stage. So those features, that features only further be built.
Good evening, madam. This is Chamla from Hyderabad.
Yeah.
Ma'am, one of the technology BERT will be there now.
What?
BERT technology. BERT. BERT.
Yeah, but
One of the technology of deep learning that.
yes.
How can include the technology in now current scenario, ma'am?
Yeah, because BERT model, no, see, always when you give the input, somebody is talking. Kavita ma'am, can you please mute?
Just a minute.
Kavita ma'am,
அந்த
Yeah.
can you
துவாரகா
mute?
பேலஸ்
Just a minute.
ரைட் சைடுல லெஃப்ட் சைடுல
Lot of noises. Anyway, BERT model, actually, it is representing your input space. So whenever we have any data, for example, if you're processing a image or a video to your computer, it's all pixel based information. But still, suppose if I pass my face, any human face will have two eyes and one nose portion and one mouth portion. These are the features which are to be extracted, right? And likewise, if I'm passing one lion face and a human face, lion is also having two eye portion, nose and lip portion. So by the time extra features which are to be provided to understand your image, like that when any input data, especially when text data is given, the BERT is with the help of a BERT, it will try to encode your data, it will represent your data better. So that's why in recent all deep learning mechanisms, our job is much reduced. It's enough to pass the modality of data, either it is text data, image or video. It will internally represent the data. So with the help of all this representation models. Then with the help of represented models, features extracted by this BERT, the model will be built inside. Any machine learning or deep learning models will be built. So in that way only it is connected. I think I have answered your question.
Okay, ma'am. Thank you, ma'am. And that BERT model is included that NLP also nowadays. That word specification will be there, no, ma'am. That already we are now using the 10 grams. And
Yeah.
BERT technology also we are using there in NLP also, natural language processing.
Yeah.
The word of specification like that.
What is the question?
It will be there in how that includes that deep learning like that.
Hello, what is the question? I don't get you.
Previously, ngram will be there, no, ma'am. That is
Yes.
that word specification process. Now we are using in deep NLP BERT model now. Why?
Yes.
Because it will be two-way transaction now. What means bidirectional transaction? That one doubt will be there. How that we are including that
We
deep
have
learning like that.
bidirectional LSTM model and all there, right? So if it is bidirectional LSTM, it looks for the forward, left to right, as well as backward direction. It will look for the n number of words together, and then it will understand the temporal sequence as well as the semantic sequence between that. In earlier days, we used to give only by n-gram. So we look for the existence of two words together, three words together. But we cannot see the very long-term dependencies also. As and when you process a long sentence, the system cannot even remember what has been encountered in the earlier stage. But with the help of recent LSTM, all bidirectional LSTM models, the long-term dependencies also can be better exposed, can be better captured.
Thank you, ma'am.
Okay.
Okay, ma'am. Shall I wind up the session, ma'am?
Yeah. Thank you.
Yeah, thank you very much, ma'am. It was really very wonderful presentation, very informative, ma'am. Thank you so much, ma'am. Thank you for your great support.
Yeah, thank you. Can I leave, ma'am?
Yeah, ma'am. Yeah.
Yeah. Thank you all.
Hope Dr. Femilda has joined in this platform. Saraswati, ma'am, please check it.
Okay, ma'am. Sure, ma'am.
Hope she has joined.
Hello. Yes, ma'am. She has joined.
Yeah, please make it presented. Yeah, good evening, Femilda.
Good evening, ma'am.
Really very happy to see you after a long time.
Yes, thank you for the opportunity. I'm glad to be here.
Okay, just a minute. So I request our department faculty, Ms. Sivakarthi, to introduce our today's session resource person. Sivakarthi, please.
Ma'am, am I audible, ma'am?
Yes, ma'am. Yes.
Good evening, everyone. It's our pleasure to welcome you all to day 4, session 8 of the ATAL Faculty Development Program on Exploratory Data Analytics, Tools and Techniques organized by the Department of Information and Technology, Velam Hall of Engineering and Technology, Madurai, supported by AICTE. Today's section focuses on big data analytics, handling large data sets in EDA, an area of growing importance as data-driven decision making becomes central to modern research and industry. We are honored to introduce our resource person, Dr. Femilda Josephine, professor in the Department of Computer Engineering, İstanbul University, Istanbul, Turkey. Dr. Femilda ma'am is an accomplished academician and researcher with a strong expertise in machine learning, deep learning, computer vision, medical image analysis, and predictive analytics. She holds a PhD in Information and Communication Engineering from Anna University and her master's and bachelor degrees in CSE from NMLA University. With more than 20 years of academic experience, she has served in reputed institutes, including SRM Institute of Science and Technology. Dr. Femilda has published extensively in reputed journals such as Springer, IEEE, and Nature Publishing Group. Her multidisciplinary research spans energy systems, medical diagnostics, water quality prediction, plant disease detection, and engine emission modeling. She has also contributed to major funded projects, filed patents, and delivered numerous expert talks. With her richest experience in handling complex data sets and applying advanced analytical techniques, today's section will provide deep insights into practical approaches for managing and exploring large-scale data. We warmly welcome Dr. Femilda Josephine, ma'am, and look forward to an enriching session. Welcome, ma'am.
Thank you for the nice introduction.
Thank you, ma'am.
Let's start the session.
Yeah, I think I have no rights to share the screen.
You have given permission.
But
Saraswati,
it says content
you-
sharing is unavailable.
Saraswati. Make it presenter, pa. Yeah.
Yes, ma'am.
Check it, ma'am. Now check it.
Okay. Yes, I can share now.
Yeah, it's visible.
Okay. Okay, thank you everyone for the opportunity given to me. I am glad that I could give the session on big data analytics handling large data sets in exploratory data analysis. So today's session, let me begin with the introduction about big data. So let me dive into the agenda. I'll be discussing about the big data. So I will give some introduction about big data and about the challenges in big data and about the big data architecture, strategies, tools. So this will be the base for the another session, which would be the hands-on session. So first about big data. So this is not a new term. It is familiar to everyone. We are handling data every day. So the data might be in different format. It might be a numerical data, a text data, image, video, audio, signals. There are different types of data. And what makes the data big is the size of the data. Might be the data is collected from different resources and the data becomes huge now. So let me get into the definition. Big data, it refers to data sets that are too large, too fast, and too complex for traditional databases to handle. So what do we mean by too large? I remember we started to work with data like maybe kilobytes of data, megabytes of data, then gigabytes, and then terabytes. And now it is like zettabytes of data. So the size of the data being processed every day is much bigger. So we are getting the data from different sources. And these data come into the databases very quickly. So maybe within fraction of seconds, we can get billions of data. So this is too fast. And so because as it is big and getting bigger, the complexity of the data should be high. Okay, so the traditional databases cannot handle the big data. So there are many other alternative technologies that are being used today in the industries so that it can handle even big data and it can process it quickly and maybe it can solve the complex problems. So why this data is getting bigger? It is mainly because of the internet. Maybe in the year 1990s, there was not much data because the internet was not used by many people. But now we can see everyone with internet and all the devices are connected to the internet. So it is just like a person is holding at least one device which is connected to the internet. So that makes the data bigger. And when we get the data, it is required that we have to process the data. So to process the data, we need the devices that could make the computations possible. So processing the data. So we need high computational power computers. We have the CPUs, then we have the GPUs, and now we have the clusters and nodes which are able to run parallel processing. And so that the data can be processed in parallel. And we have now the cheap storage devices where we can store big data. Okay. And social media, it is another reason. And everyone is using social media. For instance, when we are using social media like Instagram, when you log into an account, you are providing the data. So your data is being recorded somewhere. And when you like a picture or you like a post, your data is being recorded. And the data that you provide to someone is being used for some other purpose, maybe as a recommendation system. So once you like a video, you could see that similar kind of videos appears to you because of the recommendation systems. So social media has made this big data into a big thing. And also we have IoT devices like we have the smartwatches. When you are wearing a smartwatch, actually we are providing many data to many people, like maybe your the number of steps that you make in a day. And maybe when you carry a mobile phone, it tracks your location. When you are using a Google map, it is able to identify your source and the destination and the duration of the travel. All information are known. So there are multiple devices that captures the data, and we have the stories to store the data, and we have the computational power devices to handle the big data. Okay, so now the big data is never going to settle down. The day is gone, we are going to get into more data. Okay. So here there is a real world example I would like to emphasize. That's the Uber. We are using Uber or maybe Ola. So here, this example, the Uber processes petabytes of data to make real-time decisions. So sometimes the data has to be processed in real time. So this is an example for real-time data processing. When you open the Uber app and you type something, maybe for a location to go to the particular place, it will immediately start the processing. So it will look for the nearby taxis, maybe the shortest route, and also it has to calculate the estimated time of arrival. So not only as a customer, your information is recorded, it will also record the driver movement. So it will be where the driver is available and how much time it will take for him to reach the customer. Okay, so all these processing happens at the background and we are able to get the response. So this data has to be processed quickly. What if we try to book for a taxi, but it takes a long time? We get fed up and we may not book for a taxi from that particular application. We may migrate to another application like Ola. So it is like the different services, they have to get into the competition to satisfy the customer needs, and they have to give good customer experiences. So this kind of real-time processing we cannot handle with the traditional systems. it cannot store, process, or analyze this scale of data. And just, I would like to show the data creation growth projections. Maybe this graph says that in the year 2010, the amount of data generated is less. But in the year 2025, just within 15 years, you can see that there are zettabytes of data being generated. So the x-axis is the year and the y-axis says the data generated in zettabytes. You can see the exponential growth in the data generated, maybe 402.74 million terabytes of data are created each day. In zettabytes, that equates to around 147 zettabytes per year, around 12 zettabytes per month, and 2.8 zettabytes per week. So every day, at least 0.4 zettabytes of data is being generated. So this is not going to stop. It is going to increase, and maybe in the future, it is going to be several yottabytes of data being generated. So the question is, how do we handle this data? We have, yes, we do have the big computational power computers, and it supports parallel processing. That's the good thing about this. And this is about the 5 V's of the, big data. And you can see here the 5 V's are the volume, velocity, variety, veracity, and value. These 5 V's are very important. Among these, the volume, velocity, and variety were existing earlier, but veracity and value are recently added. And most of the literatures don't have these two, but now the new literatures comes with the 5 V's. So just we will see what is volume. Volume is nothing but, it's how much data do we produce each day, and when should we move to big data. Maybe initially we will start with 1 gigabyte of data. So this is not a big data. So when it is not a big data, we can use our traditional mechanisms. We can use our traditional database systems. We can use the traditional processing devices. But when we move to big data, we have to use the techniques that adapt to it. So when to move to big data is when you have actually maybe terabytes of data. Maybe if your computer cannot hold the data, or if your computer cannot process the data, I mean, a single node cannot process the data, then you have to go for another node so that the data can be handled parallelly. So when you have much amount of data, like set up terabytes of data, yes, we can move to the big data. And then the velocity. Velocity depends on how fast data arrives. So, and when to process it. And maybe the data arrives very quickly. For example, when we take a sensor data, the sensor will be continuously monitoring the environment, and it produces the data very quickly. And we get much data within short duration of time. And when to process this data? Sometimes some applications, they require the data to be processed immediately. For example, when you are making a banking transaction, it has to be processed in real time. So when you are withdrawing money from your account, it has to be reflected immediately on your mobile application. So there should be some kind of connectivity between the ATM machine and the mobile application, so that in between there is some processing happening, and this processing should happen within no time. But there are some other application which can process the data in a batch. For example, maybe you're not processing the data on the at the moment. Maybe you can process the data on the day, or in a week, or in a month. For example, when you get your credit card bill, it is not processed every day. The process will happen every month. So it is a batch processing. So it is actually a delayed processing. And there is another method which is near real time. It's not instant, but it happens immediately. But maybe we have a small buffer time. So it depends upon the duration that we need to process the data, the velocity. And then we have the variety. We have different types of data like the structured data, which are put up in the rows and columns that we see as Excel sheets and CSV files. We have the schema, and we have the semi-structured data like the JSON files, the XML files, and we have unstructured data like the videos, images, and audio. And actually, I'm working with many image data because I work with medical applications. And when it is a medical application or an image data, actually, it is a quite big challenge because processing the data on my computer, it takes long time, maybe 50 hours a day. It will, 50 hours it will take to process the images. But when I connect with the high performance computer, this processing will take maybe 2 to 3 hours. So it depends upon the computational power of the computer that we are using, so that the unstructured data which requires much processing duration can be handled. The fourth one is the veracity. Here it is about the quality of the data and trust. When we get the data, maybe if you are a machine learning engineer or if you are an data analyst, maybe you have to look at the data quality. If the data is not good, then maybe you should not consider taking the data, because when you apply a machine learning model on data which is which has less quality, it is not going to give you good accuracy, or you cannot expect good predictions out of it. What I mean by the quality of data, it is like whether we have the noisy data, maybe a sensor is collecting the data. The sensor, sometimes it goes into some trouble and it is malfunctioning. It has to record the data between maybe the expected range of data it has to record is between 5 to 30 degrees centigrade. Unfortunately, it is recording data with 100 degrees centigrade, which is out of the range. So that is actually a noisy data or a messy data. Or sometimes you are entering any one of the data incorrectly. Okay, instead of a positive value, it is entered as a negative value, or the data has more duplicates, it will add the redundancy. So we have to look at the quality of the data and how much we can trust the data. If the quality is good, yes, we can use it for the future. If the quality is not good, then should we still spend our time on processing the data? That's the question we have to think about. And then the final one is about the value. Why does this data matter? Okay, now everything is thought in a business perspective. Okay, if I'm working on this data, is it going to add some business value in the future? Or if there is some benefit out of this data? Okay, so if there is no benefit, then why should I waste my time on handling the data? Okay, so these are the 5 V's we have to consider while we are working with any big data. Okay, just about the foundational big data concept. Big data is now being used in at many places, and it being processed successfully due to some of the components. Maybe the first one is the distributed storage. You know, the centralized and the distributed storage. In a distributed storage, the data will be stored across multiple machines instead of a single server. So when the data is being stored in multiple machines, it is we should have some computation engine which can process the data that is available in multiple machines. Okay, but the good thing about having the data in multiple machines is because it ensures the fault tolerance. Fault tolerance is, for example, the data will be available in two different machines. So even if one machine has some problem, or if there is a failure in the machine, the data is still available in another machine. It is like how we have a backup, right? Sometimes we have some data, we store it in our computer, we will send it to our email, and maybe even we have it up and copy in a pen drive. Okay, so here even one of the method fails. For example, unknowingly you deleted the file that on your email, but still you have your data available on your computer or on your pen drive. So it is ensuring the fault tolerance and scalability, because we are distributing the data, it is scalable. So, in the cloud computing concept, the devices or the nodes can be scaled. So as the nodes are scaled, the data storage becomes scalable and the data becomes highly available. Okay, when you put all the data within one computer, it is very difficult to look up for a specific data. But when you are putting your data in multiple machines, and when you have an index of what data is available, what type of data is available in a machine, then you will be able to pick the data quickly from the machine. So it is highly available to the customers when there is a demand. And for example, we have the Hadoop distributed file system, we have the Amazon S3, and we have the Google Cloud Storage. Hope this is not a new information to you, but just I will show you the HDFS architecture. Here we have the name node and the data nodes. These two nodes are the important nodes, and this is the primary node. Actually, this node does not store any data, but this node will have the metadata about the data. So it will know that where the data is actually stored in which data node the data is stored in. Okay. For example, here there is a client. The client is trying to read the data. So the client actually requests the name node, and the name node knows from the metadata where the data is available. And the replication, you can see this block of data, it is available here, and also it is available in another data node. So even if this data node has a failure, still we are able to recover the data. And you can see here, this is the client who is trying to write the data. When the client is writing the data, it is written into our more data nodes to maintain the fault tolerance. And this metadata holds all the information about the data nodes and what kind of data they hold. So it is like an index page in our book, right? So in maybe the number of pages in a book might be like 400. We do not know where the actual information you are looking for is available. But at the beginning, you have an index page. So in the index page, you can look at the metadata, right? The chapter, the sections, and the topics. So you will be able to easily migrate into the particular page number and look for your information, okay? So this is a HDFS architecture, and it is maintained by Hadoop. And this architecture was actually the first open source architecture. There were many distributed file systems, but they weren't available as open source, but this was the widely used open source architecture. And then we have the distributed compute. So we have the distributed storage. So the computation also has to be distributed. If it is centralized, it is going to be an overhead. So all the computations are happening in a distributed manner. So the computation happens on many machines simultaneously. So parallelly it will happen. And the frameworks distribute tasks and aggregate the results. So maybe when you are looking for function. For example, you are looking for group by function. Okay, you have a big data and you're trying to have some data out of it using the group by function. Actually, the big data is split and it is stored in different machines. So all the machines will simultaneously run this particular function and it will pull the information, and then finally it will be aggregated and it will be given as a result to the user. So the framework distribute the task. It will distribute the task to the computers or the machines and then aggregate the results and give it to the users. Here we have some examples like the Spark, the Hadoop MapReduce, we have the Dask. Maybe Spark we will be discussing in detail because I will be discussing about Spark for the hands-on. Okay, so Spark, it is actually an in-memory distributed compute. Okay, so whatever processing is happening, it will happen in the memory. It will happen in the RAM. So it is fast, whereas in Hadoop, it will do it as a disk-based compute. Okay, so whenever we place a request, it will look for the data in the disk and then it will compute and then it will give the result. So this makes the Hadoop MapReduce a slower one compared to the Spark. And we have the Dask, which is a Python native parallel data framework frame computation. Actually, it uses pandas, but it uses multiple mini pandas. Okay, so that it is also doing a kind of parallel computation. In this picture, you can just see an overview of the distributed compute. We have the input, and the input is broken and given into multiple mappers, and the mappers will be having the key value information. Okay, so maybe each mapper will have multiple key value information, and these information will be given to the shuffler, and the shuffler will be sorting the information, the key value pairs. Maybe multiple mappers can have the same key value, so same key, so it will shuffle and sort it, and then it will reduce it and give it to the reducer, and the reducer will give the aggregated results to the as output to the maybe the user. Okay. Next one is about the parallel processing. So we have the distributed storage, distributed compute, and now the parallel processing. So when we have a distributed compute, that means parallel processing has to take place, right? So workload is split into small tasks and executed in parallel. So maybe we have the operations like the group by. So you have a data set, maybe 10 terabyte size, and maybe you have 10 machines which are distributed, and maybe I'm breaking down my 10 terabyte of data so that each machine will have 1 terabyte of data. Okay, so when I apply a group by function, what happens is all the 10 machines will start to execute parallelly, and that is the parallel processing, and it will look for the one, each machine will look for its 1 terabyte of data, and it will apply the group by, it will fetch the result, and it will give it to the reducer. And the same thing will happen on all the 10 machines. So that will be some 10 outputs which will be aggregated, and it will be given as a result to the user. And we have the joins. It is like the SQL joins, the basic join, but it is happening parallelly in 10 different machines. Filtering, when you are filtering with a column, for example, filtering data that were created during the year 2025. Okay, maybe when you go to Google Scholar, you have an option that you can see the articles that are published maybe from the beginning, or you can even apply some filter, like show me the articles which are published after 2019 or published during 2025, right? So when you apply a filter, at the background, actually the distributed computing is happening and parallel processing is happening. And the statistic scale to billion of rows. So we have well, the statistics, that means the percentile. So maybe 1 to 100 percentile. So we have the statistics, the mean, the standard deviation, the minimal value, the maximum value. So these all populate into billions of rows. Okay, so everything is made faster with the help of the parallel processing, and it enables the exploratory data analysis even on multi-gigabytes or data big data sets. Okay, so just it is a picture to show that we have the storage, the data which is stored in multiple devices or machines, and it is processed parallelly, and the results are aggregated and given to the user. And then we have the data locality. So this is one of the wonderful concept, because here generally we will have the data in our computer, right? When we are doing any processing, we bring the data to our computer, and from the computer we will process the data. So our CPU will be there to process the data, and we see the results. But with this big data, what happens is, instead of moving the huge data to the computation layer, move computation to where the data lives. That's a good thing. Why this is important is because imagine that we have like zettabytes of data, okay, or terabytes of data. So these terabytes of data are stored in the storage. And if you are trying to make some processing, we have to bring the data to the computational device. So we will bring it to the computational device through some networking technologies. So we have to transfer the data from the storage to the computational devices, which will cost more, okay? And it will delay the process, and there might be some loss of data, okay? So that the processing might not be that successful. Okay, so to overcome this, what big data suggests is to move the data computation to where the data lives. Okay, and so this reduces the network transfer cost, and it improves the performance significantly at scale. Here we have the example. In this example, it says the data locality in Hadoop. So we have the data available in different machines. Okay, so we have the different data. So when there is a query, for example, a group by query, this query will trigger the algorithm to be run on the devices or the machines where the data is available. Okay, say the data is available in this machine, then the algorithm runs here or the query runs here. Okay, so from the storage, the results will be given to the reducer, and the reducer will aggregate the data and it will give the result. Okay, so this is a major concept. It is a breakthrough concept in the big data because it is trying to reduce the network cost and the network delay and the loss of data. Okay, and about the last the concept is the cluster architecture. So with cluster architecture, the big data system, it looks like a cluster, or it runs on a cluster with multiple components. Okay, so the cluster will have the driver nodes, the worker nodes, the executors, and the cache. So this is an example for the Spark cluster. So here, the driver node, it is like the brain. Okay, so it decides what to do, what kind of task to do, and it coordinates the job, and it stores the execution plan. Okay, so it decides. It's the deciding factor. Okay, it's like the human brain which decides what to do. Okay, and then we have the worker node. It actually runs the actual computations. Okay, so here we have the executor, which is actually the processes that is running on each worker. It is the processor. And we have the cache. You know what is a cache, right? So cache is a ready memory. So keep the data ready in RAM. Okay, so if your data is available in cache, that means you will be able to process the data quickly. Okay, if it is available in your disk, then it will take a long time because we have to load the data from the disk to the RAM, and then it has to process the data. But here it will keep the data ready in RAM so that the cache is helping to keep the data ready in the RAM. Okay, so the data, if it is looking for a data, it will just look at the cache. Okay, if the data is available in the cache, it will be picked from the cache and it will be processed immediately. So it is trying to speed up the process. So in a cluster, we will have more partitions. So that means we will have more parallelism. Okay, so this is the fundamental concepts that is behind the big data. And I would like to show a big data architecture as an overview. Maybe you can see at the left-hand side, these are the initial points. We have the data sources, maybe through the internet or through some social media or through some emails. Okay, we get the data. So this is the source of the data. And there is the data ingestion layer and the data collection layer, which will collect the data and which will coordinate the data. And then the data will be stored in the storage. So here we have the 3 different data storage like the S3, the HDFS cluster, and here the data is stored, which is the data storage layer. And top of it, we have the data processing layer. Okay, so this data is processed processed and it is processed because there was some query. Okay, so we have the data query layer. So the data query layer, maybe the Spark, or we have the SQL, or we have the Amazon. We have so many devices here, and the query layer will provide the data, and there is an analytics engine which will provide the statistics analytics, semantic analysis, predictive modeling, and text analytics. Okay, so maybe the machine learning, all the kind of analytics will be happening here, and it will be given as the output to the data visualization layer, where the users can see the results. Okay. And we have the data security layer, which holds the security of the data. Maybe it holds the access control list, like who can access the data and who cannot access it. Okay, so it holds the access control policies. And we have the data monitoring layer, which will monitor the data storage. It will keep in hold of the inflow and the outflow of the data. That means how many data is entering a day. It is a kind of a log manager. Okay, so it will be monitoring everything. So now the question is, why traditional EDA breaks? Okay, we are just discussing about the big data, but we should understand why traditional EDA cannot be helpful for the big data. Okay, the first thing is because of the RAM limitations. Okay, when we are using pandas, actually it loads everything into the memory. Okay, so maybe if your computer is having 8 GB, okay, then of memory, then it can handle maybe maximum of 4 GB of data, maybe, or 6 GB of data. Okay, so it crashes or slows down once data exceeds this. Okay, on high, high what the computational power computers. Okay, and the second one is slow joins and aggregation. So imagine that you have a data set. The data set is having tens of millions of rows, okay? And it is available as a single data, okay? And you are processing the data using a single node CPU, and you're trying to execute a query like group by. So this group by has to look into the tens of millions of rows. Okay, it will take long time to execute this query. Or if you try to merge 2 tables, okay, again, it will take long time because of the size of the data. Okay, maybe if you have only like 100 rows of data, yes, it is easy to do a group by operation, or you can easily do a merge operation or a sort operation. But when you have like millions and millions of data, then it is very expensive, because a single node cannot handle this. Okay, it will go into the failure. Okay, so this is not suitable for big data. And the high dimensionality. High dimensionality, what I mean is the number of features, okay, number of columns in the data set. Okay, it's the wide data set. So a data set will include maybe a structured data, will include the rows and the columns. So the columns, as it increase, your data set is becoming complex, and any analytics on it, it becomes complex. Okay. For example, when you're applying some machine learning algorithms like the K and K nearest neighbor, it is actually having one of the limitation that it enters into the curse of dimensionality, right? So as the size of the dimension is getting higher, then there is a problem with handling the data because of the correlation checks and the feature scans and also the memory fragmentation. Okay, so we cannot apply a traditional EDA on the high dimensional data. If you're trying to visualize a high dimensional data, maybe you are applying correlation map, no, a heat map. Okay, a heat map will help you to understand the correlation between the features. So when we are using the Pearson matrix, we are trying to visualize maybe one feature and another feature has a correlation of 0.83. We understand, yeah, they are highly correlated, and another feature is less correlated. Okay, so we understand the correlation. But here, this data set, which is huge, you cannot visualize it as like we see a normal or a small size data. Okay, so it is a problem with big data and expensive pre-processing. It takes like tasks like missing value imputation, right? So when we are getting any data, we try to pre-process it. We look for cleaning the data. So we will look for any missing value. If there is a missing value, then maybe we will apply some imputation method. Like we apply the mean, we apply the median, or we apply some interpolation method. We apply many things, right? And we try to do some encoding method, maybe a categorical encoding, or we will be trying to do some kind of encoding, maybe one hot encoding. So everything becomes expensive, and type conversion, maybe the data type conversion, it takes minutes to hours instead of seconds. Okay. And the another big thing is the data imbalance. Here, when you have categorical data, okay, for instance, you are working with us, you are going to work with a supervised learning algorithm. So it has the target will have the categories, and the categories may be like two categories, positive and negative. Let's take like we have 10 millions of records belonging to one category, positive, and just 50,000 of data belonging to another category. Okay, so if we try to make a balance on this, okay, maybe when your data use case is much sensitive, you go with oversampling, maybe creating synthetic data. So this synthetic data will increase the size of the data. Okay, so when minority classes are tiny relative to millions of records, the nice sampling breaks and metrics become misleading. Okay, and we need to balance it using oversampling method. It fails because of the big data, and if it is handled within a single machine. And the next one is about the data quality. It's the data quality issues multiply. Okay, so the outliers. When you have an outlier, then the machine learning models will actually skew towards one direction. Correct. For example, when you are working with a linear regression, it works with the equation y is equal to mx plus c. So it will try to draw a regression line by adjusting the values of m and c, and it looks like it adjusts the regression line by adjusting the error. Okay, so the error will be tuned by adjusting the values of M and C. So if there are more outliers, then what happens is the linear regression line might not be optimal, and it can give more error, and maybe the prediction results might not be good. Okay, so outliers might be a problem, detecting an outlier, because you need to see the outlier. The duplicates, when you have millions of data, you cannot visualize the duplicates easily, incorrect entries, and they require distributed cleaning. Okay, so if you need to clean something, okay, in real life also, right, when we have a big task, if it is done by many people, it can be solved in no time. But if one person is doing all the tasks, then it is going to be really a troublesome day and a tiring day, right? So again, about the memory constraints in big data. Okay, in big data, as I mentioned, when you are using your computer, there is a memory constraint so that the processing will take hours. So dataset too large for RAM, the traditional tools like pandas load the entire dataset into the memory. When the dataset size exceeds system RAM, the operations start failing. Okay, the operations will start failing because even maybe you have tried loading a data set, maybe you tried to visualize the data set which is too big. Okay, it will take long time. Okay, especially when you are working with some online environment like the Google Colab, right? They fail because they cannot handle big data. Okay, so fixes are, we can do the chunk-based processing, load data in small pieces using chunk size, and process each chunk independently. Okay, so maybe we will be having like a 3 core processor. So the 3 chunks of data will be processed in 3 cores independently, and then the results will be aggregated. Or we can use the Spark data frames. The Spark distributes data across multiple machines or CPUs. It supports the distributed joins, lazy evaluation, and fault tolerance. Okay, distributed joins, what I mean is because the data set is being broken and it is stored in a different storage, the processing will be happening at the different computing machines. And so when we are doing a distributed join, so each of the machine will be performing the join function. Okay, and so parallelly the distributed join function is happening, and finally the aggregation will happen. Okay, so this helps the results to be given quicker. Okay, the lazy evaluation is in Spark. It does not do a eager evaluation. Okay, so it does a lazy evaluation. For example, when you are having a sort function on a column of data, it will make a directed graph, okay, DAG graph, and it will not immediately show the results, but it will wait for another command to trigger the result. Okay, for example, sort of, then it will wait until it has a command like show off so that it can show the results. Okay, until that it becomes idle and it does no background processing there. Okay, what I mean is it's like a lazy learner, like the KNN. Okay, if you remember, if you know the machine learning algorithm like the K nearest neighbor, it is a lazy learner. It is a non-parametric. Okay, so during the training time, it does nothing. It will be waiting until you show a testing data. During the training time, it just stores the data and it will wait for a test data. So when there is a test data available, at that time, it will try to map with the data points on the training data, maybe using techniques like the K nearest neighbor or the Euclidean distance method. Okay. And Spark, it also has the ability of fault tolerance, because even if one of the node fail, there will be copy on another node, and it can handle the fault tolerance. And also we have the DASK data frames, which will scale pandas syntax using parallelism. Okay, so basically it uses the pandas, multiple pandas, and it will run parallelly, and it works on local machine with multiple cores. Okay, so when you are working with a DASK, actually you are working with your local machine, but it is with multiple cores. It gives a kind of illusion like the multiple cores and distributed clusters. Then we have the use columnar formats like the Paki. So in Paki, it loads only the required columns. Okay, I will be telling about what is Paki in the upcoming slides. Okay, so Paki loads only the required columns. There is some difference between a CSV file and the Paki. We will try to understand that. And faster scanning with predicate push down, because the Paki will be working in a columnar format. It's not like a CSV file, which will be reading each row, okay, rows one by one. It never does that, okay? So, and also it has an internal compression mechanism, which can reduce the size of the file. So for our practical, I will be executing our queries with a Paki file, not a CSV. Okay, maybe we will have a comparison on CSV and the Paki file. And then we have to discuss about the CPU and compute limits. Why Pandas struggles, okay? As earlier, Pandas, it works only with a single machine, and it runs entirely on one computer. It has no cluster support, okay? So there is no parallelism at all. So it has a single core execution. So most operation execute on one CPU core, even if your laptop has 8 or 12 cores, okay? It will just use it. When you are using Pandas and when you are manipulating your data using Pandas, then it will just use one single core, okay? So this is one of the drawbacks with Pandas. But when we are using Spark, it will split the data frame into partitions, and it processes them across many machines. For example, if your laptop has 8 to 12 cores, it will partition the data frames and it will process them in 12 cores of your machine. Okay, it does the multi-core execution. Each worker node can use all its CPU cores. Example, if there are 10 nodes, and each node is having 8 cores, then you will be having 80 cores processing in parallel. Okay, but with Pandas, that's not possible. And so that's a drawback here. And this picture is just to show, this is the marker master. This is the Spark context. This is the master and the worker, and there is the executor. So whenever you are giving a command, okay, the driver will be the brain for the execution, and the controller is the master, okay, and we have the workers which will be executing the task in parallel. Okay, so these are the CPU cores that are executing in parallel, and then it will provide the combined result to the master, and the master will respond it to the driver, and so the client. And another challenge is the visualization challenge. Okay, I just mentioned that with a small size data set, you can visualize your data easily with a scatter plot, or you can plot a box plot and see if there is an outlier. Okay, or you can, if you need to understand the correlation between the features, then just you can plot Pearson correlation matrix and you can see. Okay, but when you have big data, okay, if you plot as the data points as a scattered plot, okay, if you have millions of points, okay, it will produce a kind of a solid blob. No, you cannot see anything, just a group of data points, but you cannot find any insights out of it, or you cannot interpret the data, right? If you have the different classes of data, maybe the data points will be put merged together, so you cannot understand the pattern of data. Okay, so tools like the matplotlib or the seaborn slow down drastically or freeze. Okay, so we cannot use the basic matplotlib or the seaborn libraries that we use every day. Fixes, we have like sampling. Okay, instead of trying to visualize the whole data, maybe we can see the subset of data. Okay, so maybe 1% of the data we can visualize. Okay, this is a fast good for initial EDA. Okay, maybe you have like 10 million of data. Maybe you can just try to visualize like 10,000s of data, a sample data. No, it's like to taste food, to understand, know how the food tastes. It's not required that you have to eat the entire food, right? Just you can taste a bit of it, you can realize the taste, right? Similarly here, to know about the data, maybe you can take a random subset. Okay, we can make a random sampling and we can do that. And also we can do a stratified sampling. So stratified sampling is different. Here, stratified sampling is applicable when we have categorical data and the categories are imbalanced. Okay, I mean the categories, the classes. Okay, for example, you have like 3 classes, a positive, negative, and neutral. You have 3 classes. Maybe you have more data on the positive side and medium data on the neutral side, and negative data, you have very less data. Okay, so here when you are making a random sampling, sometimes it can be like the random samples might not include the data of the minority class. Okay, so when you apply a stratified sampling, what will happen is the stratification will try to balance the ratio of the classes. Okay, in all the samples. Okay, maybe the ratio is 1:, maybe 5:2, maybe 3. So it will try to have the same ratio in all the stratified samples. Okay, here the example we can see, we have the entire population. We are trying to apply the strata here. And from the strata, a random selection is based, okay, is taken. You can see in the when we are trying to make a group of the population, we have the green people, the blue, the red, and the blue, right? The light blue. Here, this light blue has lesser people compared with the darker, I mean, the light red has lesser people compared to the dark blue. Okay, so when you are applying a stratification, your sampling will be like you will be having equal number of people in the same equal number of people under different classes. Okay, so that is stratification. It will try to balance the ratio. And also we can apply the approximate aggregate algorithms. Okay, instead of computing the exact values of billions of rows, we can approximate the quantiles, maybe the top 25 percentile or the bottom 25 percentile, okay, or the 50 percentile. You can approximate the quantiles and you can see, or you can have some hyperlog unique counts. Okay, so whenever when you have a very big data and you need to you need to count the number of data that was collected in a particular day, it's like it will be difficult if you are doing a count every time when there is a query. Okay, instead there will be you can have a log. That log will hold the information about the number of people use the application on a particular day. Okay, so it is a hyperlog log and the sketch-based correlation estimate. So the correlation matrices will be based on some subset of data, not the entire data. Okay, so visualization actually is a big challenge when the big data is big. Okay, and about the data quality, the data quality is a big problem. I mentioned it earlier. So we have thousands of data. It grows into millions and billions of rows. Small errors multiply into massive problems. traditional cleaning techniques become too slow or incomplete. Okay, for example, missing values across millions of rows. Okay, so how do you find that which row has the missing value, right? And maybe if you are trying to print using a command to see the missing value, still filling the missing value will be a challenge. Okay, whether you apply a median method or a mean method, or should we go for an interpolation method? Okay, so all these takes much time. Okay, so it will be a big problem. And identifying the duplicate records, whether there is a duplicate record. Okay, if just 10 rows, as we can easily say that there is a duplicate record, but more data, the duplicate record goes into a problem. And outliers, yes, it is again another problem. And noisy data is the inconsistent data. The sensors may record the data incorrectly. And again, inconsistent types. Okay, so the, inconsistent data and inconsistent types is the maybe column should belong to the integer type. Okay, but there are some of the entries in the column that is written as a string. Okay, so that makes a confusion, and this is a major problem in the data quality. So what we can do is we can do the imputation at scale. Okay, at scale, what I mean is when we are using a distributed system, the distributed systems they themselves will be handling the imputation. Okay, so if there are 100 distributed systems or 100 distributed nodes, they do themselves at scale. And so we can apply the mean or the median method for numeric values. And we can do the distributed deduplication. So duplicate records, how do we find it? If there is duplicate data, then a hash value will be assigned to the duplicate records so that two records having the same hash value can be removed. Okay, so that's possible. And we can handle the outlier by the quantile based filtering. So the top 25 percentile we can remove. Okay, or the bottom 25 percentile we can remove. Or we can give some explicit validation rules and constraints, like there should be no entries like age is greater than or equal to, age should be greater than or equal to 0. It should not be less than or 0. And the amount should be greater than or equal to 0. And country must be a valid code. We can write the constraints. And also we can have some data type standardization, converting data types in pipelines. Okay, so if there is a date column, all the date column entries should be of date type. Okay, it should not be a numerical type. Okay, so this kind of fixes can be done at the scale. Okay, what I mean, the scale is by each and every nodes in the distributed system. Okay, not in a single node. Okay, now we might be working with the CSV files, right? So see, we are all familiar and we are comfortable with using a CSV file. Okay, but when you are using big data, it is not recommended to have a CSV file. Okay, so CSV is bad for big data. Why? Because there is no compression. Okay, so compression means the size of the file will be huge. Okay, and CSV file, it is a plain text. Okay, and maybe if the size of the CSV file is just 10 GB of data, okay, it may stay 10 GB, but or even bigger in RAM. Okay, because this 10 GB of data will also, when you are doing a processing on this data, it will also have the schema information, the data type information. Okay, so when you are using it in the RAM, when you are processing the CSV file in the RAM, it can get bigger, and the your computer can break. Okay, so more data transfer, slow scanning. Okay, so here we need to have the data in more better way. Okay, so we have the row based format. Okay, the CSV is using a row based format, That means the CSV reads the whole row even if you need only one column. Okay. You remember a data set that is in the form of a CSV file. You have the rows and the columns. And when you are looking for only one column, for example, you have the column like the age, the experience, the salary. Okay. So we have 3 columns, right? Just if you are trying to look at one column, okay, maybe the salary, okay, it will try to read it row wise. From the first row, it will pick the salary. From the second row, it will pick the salary. Okay, so it will take much time. It's a slow column, it's row-based format. So when you are trying to look at a column, it makes the slow column access. Okay, it is bad for big data where queries often select 2 to 3 columns from 200 plus columns. That might be more than 1,000 features available. From the 1,000 features, if you're looking just like only 2 or 3 columns, okay, what if we use a CSV file? The CSV file will start reading each row. Okay, so each row, and actually internally it is reading the columns also, but we are interested to know only 2 or 3 columns. Okay, so it is taking more scanning time. Okay. And no schema, everything is a string. The CSV does not store the data types. There is no external schema available for the CSV file. The system must infer the types every time. So when you are processing with a CSV file, every time the system has to infer, okay? That's another big drawback with a CSV file. And as I mentioned here, it's related with the slow column access, slow parsing, line by line processing. So CSV requires splitting by commas, handling codes and escape characters, extremely slow for multi-gigabyte files. Okay, so it's not a good idea to have a CSV file for big data. Okay. CSV is simple and human readable. Yeah, I agree that, but too slow, too large, and too inefficient for big data workloads. Okay, now I would like to replace CSV with a PACU file. Okay, a PACU file is better because it has a schema. Okay, so PACU is better for big data. Okay. It has the columnar storage. Okay, PACU stores data column wise, not row wise. This means the Spark that we'll be discussing, the Dask, the BigQuery can read only the columns needed instead of scanning the entire file. If you are using a CSV file to look at a column, it will scan each and every row. But with the PACU file, it has the ability to move into the specific column and just it can pull out the column information and give the response to the query. Okay, so that's a good idea behind the PACU. And it is highly compressed. PACU uses advanced compression algorithms, like internally they do have the compression algorithms like the Snappy and gzip. This reduces the file size by 60 to 80% compared to the CSV file. So it can be easily handled, and it can be, even if we are trying to transfer the data file through the network, it is quick. Okay, so it is highly compressible, and it has a schema embedded inside. Okay, PACU stores column names, types, metadata inside the file. Okay, for example, we have this table, the trip ID, the passenger count, the fare amount, the trip distance, and the trip date. Okay, so it will prepare a schema. Okay, so it stores the schema. That's the metadata inside the file. Okay, for example, when you are initializing a PACU, a Spark session, okay, and when you upload a PACU file, it will come up with a schema. Okay, so it says that the schema, for example, the trip ID is integer, and it says that this cannot be ignored. There should be a value for the trip ID, nullable equal to false. Then passenger count as integer, okay, and maybe there can be some missing values, okay, and fare amount double, and so on. Okay, so it has a schema for what you have in your data set. Okay, so it is not required for machine to wait to for a schema to be generated when the data set is loaded. Okay, so Paki files, they come with a schema. Okay. Okay. Select star from sales varrier is equal to 23. What I mean here is that Paki can skip reading entire chunks of data and just it can look at a column. For example, if your data set has a column called year is equal to 2023, it can just come and look at the column year and it can fetch the data belonging to the year, I mean the year 2023. Okay. Now, about the Apache Spark, we will be working with the Spark. So that's the reason why I have added this. Apache Spark is a fast distributed computing engine designed for processing large scale data sets across clusters. Okay, so it is a computing engine. We have many computing engine like the MapReduce. This is a computing engine. And we have the key features. Okay, it is distributed. Okay, so data automatically split across many machines. So for example, in your computer, if you have 2 cores, the data will be split across the 2 cores. If you have 10 cores, it will be split across the 10 cores. Okay. And one of the important feature about the Apache Spark, it does the in-memory computation. Okay. The processing happens in RAM much faster than the disk-based system. Okay. So if it is a disk-based system, it will be like every time the disk is here, the RAM is here, and you're requesting for some data, it will fetch from the disk and then come back. Okay, so it will be, the processing will be long. Okay, and unified analytics engine, it supports the SQL, it supports the streaming, it supports machine learning, and it supports the graph processing. Okay, so it is a unified analytics engine and it supports the fault tolerance. Okay, lost task automatically re-execute. Okay, if there is some problem with a task, since it holds a copy of the task in another machine, yeah, it can handle the fault tolerance. And it does a lazy execution because it builds the DAG execution plan before running the job for efficiency. Okay, so as I told you, it's a lazy execution method. That means it will wait for a command. So when there is a command, it will execute the plan. Okay, so it will not it will not show the results of the plan before the command. It will wait for it. And it supports language like Python, Scala, Java, and R. Okay, so we will be working with PySpark. And actually, Hadoop, as I told you, that it's the first open source architecture. Okay, I mean distributed computing architecture or a cloud computing architecture. And there are many people use Hadoop, MapReduce, but Apache Spark, it dominates Hadoop MapReduce because of these reasons. The factors are the speed, okay? And the Spark, it is 100 times faster than the MapReduce. And Hadoop, it is faster than the traditional system. Why? What makes the Spark faster is because this has the in-memory processing, but Hadoop, it does disk-based processing. And it is written in Scala, okay? And this one is written in Java. And but you can use Python. Okay, PySpark is available, so it is a unified language. It can do the data processing, batch processing, real-time processing, iterative processing, and interactive and graph processing. But here this can do only a batch processing. It's not suitable for a real-time processing. Real-time processing, it is much required for many applications. Okay, and ease of use. Okay, so when you have to use Spark, okay, the Spark is easier than Hadoop. Okay, it's yeah, the architecture behind Spark is actually easier than Hadoop, but Hadoop is complex and lengthy. And again, it supports the caches, the data in memory, and enhances the system performance. But Hadoop, It doesn't support the caching of data. In memory is available here, but here there is no in memory processing. Okay, so this is a difference. And so Apache Spark, we have a unified language, which is another which is supported with Python. So PySpark is the Python API for the Apache Spark. Okay, it is a powerful tool for large-scale data processing. And Spark has four main languages: Apache, PySpark, Python, but PySpark, it uses the Python, Scala, Java, and Spark R. Okay, so you can use anything out of it. If you are interested with Python, maybe PySpark, or if you're interested with R, you can use Spark R. Okay, but I prefer to use PySpark. PySpark provides high-level APIs for distributed frameworks, SQL operations, for machine learning, because it holds internally the machine learning libraries and the streaming workloads, maybe the real-time processing. Okay, it supports these high-level APIs. And comparing Pandas and PySpark, the PySpark, it is a distributed cluster. Okay, and Pandas, it executes only on a single machine. And here the memory usage, it uses the entire data set in the RAM. But here PySpark, it distributes across the different nodes. And parallelism, it is mostly single core. If you are using the Dask, it is actually a combination of multiple Pandas. Okay, then yeah, it uses parallelism. But with just Pandas, you don't have a parallelism. It just uses a single core. PySpark, it has the multi-core and multi-node, so there are chances of multi-parallelism. And dataset size limit is less than 10 to 20 GB. Okay, because it depends upon the capacity of your machine. And PySpark, it has no practical upper limit because it can handle terabytes of data. And as there is a scalability, it is possible to scale up. You can add more storage, you can add more distributed computing engines. Okay, so that it can support terabytes, millions of terabytes of data. Okay, and fault tolerance in Pandas, it has no fault tolerance because it has no replica. Okay, just it will be using the machine data set. But PySpark, yeah, it has, because it has many copies and different nodes. And speed and large joins. When you have a big data set, when you're trying to join two large data set, okay, then the Pandas, it is much slower. But with PySpark, it is fast because of it allows parallel join algorithms. And the best use case when you are using a local explanatory data analysis. Okay, for example, if you are using a medium-sized data set or a small data set, okay, maybe most of the data set that is available in Kaggle, yeah, maybe you can do the EDA with the Pandas. But when you are using a big data, then I don't recommend you to use Pandas. You have to go for the PySpark, and maybe you have to use a Paki or instead of having a CSV file. Okay. Yeah. So this is to wind up the session today. So just today we have discussed about the big data. Okay, what is big data? And some of the comparison between Pandas and the CSV files, and about the 5 V's that define the big data. And then we try to understand the problem with the traditional EDA and so how to fix the problem with the traditional EDA so that it can support the big data. And I try to just explain the components behind the big data architecture, like the distributed storage and the distributed compute. And then we have the comparison between the PACU and the CSV. Why we prefer to use the PACU. And another one is the comparison between the Spark and the Hadoop. Okay. And we discussed about the different big data EDA uses. Okay, it is helpful for the optimized storage, for the distributed cleaning techniques, and maybe it has many algorithms running behind it so that the data is not moved to the computational unit, but the computational unit is moved to the data. Okay, so now I'm waiting for your questions.
Participants, you can post your query in chat box.
Let me look at the chat.
Someone are Dr. Kamlesh, yeah. You can raise question. Okay.
Ma'am, am I audible, ma'am? Am I audible?
Yes, yes, please.
I'm Dr. Kamlesh, working as a professor at IT department. And first of all, the session was really interesting and it's wonderful. The way you presented all this information in the cohesive manner, so it's very good. And my question regarding, we are discussing about the visualization challenges, right?
Yes.
Sorry.
Please.
Visualization challenges, right? So my question, as we deal with big data, definitely the ma'am, am I
Yes,
audible?
yes, I can listen. Yeah, I can
Yes,
hear
yes.
you.
Since we deal with big data, the dimension of the data will be so high, right?
Yes.
So, of course, this the dimensionality, high dimensionality will be will pose a very big challenge for visualization. So,
Yes.
in that case, you know, what specific technique used for dimensionality reduction? Yeah. If so, why
Okay,
you are choosing the technique?
Okay, we have different methods for reducing the dimensions. Maybe we can go with some kind of feature selection algorithms. Maybe we have say, for example, we have the basic machine learning algorithms like the random forest, which can help us to rank the important features. Okay, so maybe if you have a very big data set, not all the features will be important. So these kind of algorithms can help you to rank the features, and based on the rank of the features, you can select the features. That's one way. The other way is you can do a feature extraction. Like maybe you are applying a principal component analysis. Okay. So this principal component analysis can help you to extract the features. When we make a feature selection, actually, sometimes we may lose some information. But
Yes,
with
ma'am, yes.
feature extraction, we are not losing any information, just we are extracting the essence of the features. We are reducing the dimensionality there.
Okay. In that case, I've got another one question regarding the same visualization challenges. So there are a lot of tools available, right? So a lot of tools available. And how do you select a particular tool for a particular job? What makes the choice of tools?
It depends upon the use case.
Okay. Use cases, and you know, for example, if it is the use case of agriculture will be totally different from the use case of financial domain, right?
Yes, the use case is different. What I mean is maybe how much important your data is. Okay. So sometimes you need to visualize all the features in your data set. Okay. But it is not possible to do so with all the features because it's going to look like a solid. So better we are going to do a feature reduction and then we can see. And again, there is no hard and fast rules like you have to go for this tool. Okay. You can go with that is optimal for your use case.
Okay. Thank you. Thanks a lot.
You're welcome.
Madam, hello.
Yes, I can hear you.
Yes. Madam, what is the minimum system requirements while handling such a large amount of data, which is in terabytes? Like,
Maybe you have to look for some cloud environment. That would be better. Because if you are using a high performance computer with cores, yes, then you can have the terabytes of data. But your normal system, I think it's not enough for big data, maybe terabytes of data. So you can get some cloud environment.
okay, thank you.
Shall we wind up the session? Any other question? Shall we wind up the session, ma'am?
Yes, for me, it's okay if there is no question.
Yeah.
Ma'am, audible, ma'am?
Yes.
Ma'am, I'm planning to establish one startup, ma'am.
Okay.
Can you give me that any how to store my data and database more database I'm having now. So
Okay.
low cost database can I store anywhere? Can
You can
give that
purchase a cloud storage. That would be better. Maybe you are interested with some cloud storage, then you can purchase some cloud storage. Maybe you can get the storage from the Google Cloud Platform or from AWS. Any cloud storage you can use.
Okay, ma'am.
Hello.
Thank you, ma'am.
Hello.
Okay.
Hello.
Yeah.
Ma'am, I'm from my name is Rajni and I'm from the Delhi, from the Technion Institute. I want to know about that we have already Power BI and Power BI services also. So we can use it as a big data as a integrated by the cloud computing and other Pythons also here. So we can use it. So then is it okay? There is a tool of many tools in Power BI that we have EDA options also here and data transformation.
Yes, for visualizing, yes, you can, but you have to think about the data storage. If you are having a cloud storage, yes, that will be good.
Okay. Thank you, ma'am.
I think you have the cloud storage, right?
Actually, we can already if we have a cloud computing data on the platforms, so we can easily extract the data. Yeah, we are already connect the data from the site, and we have already transformation tools for where we have cleaned the data, and so on. We can easily visualize.
Okay.
Okay.
Hello, ma'am.
Hello.
Hello. Hello, ma'am. Thank you for sharing the email ID. Right now, I have looked for your research. You have done a lot of work in a brain tumor. So, ma'am, I am currently working in that area. So, the 3D images, I need a little guidance. Can I send you an email regarding that? Because it is a session going to be too long for that. Is it?
Yes, sure. I'm interested. Yeah, I am working
Okay, ma'am.
real data images, yeah, maybe I can help you.
Ma'am,
Yeah,
ma'am,
ma'am, definitely. Thank you so much, ma'am.
ma'am.
You're welcome.
Sorry, ma'am. One final last question. Sorry to interrupt. Once again, Kamlesh from this Velamala Engineering College. So apart from this, if you want to introduce this kind of data engineering concepts to our students, what are the tools can be taught, or in what fashion we can get those tools to students? In what way they should be delivered to the students so that it will be useful for them to get placements? In placement point of view, what are the tools that you recommend for data engineering task?
Maybe for data engineering task, it is better that they can go with the basic pandas.
Okay.
And yeah, for the visualization, they should know about the matplotlib, because these are the basic things, no?
Yeah.
And it
Yes,
is
ma'am.
easily understandable. Okay, that's
Yes, ma'am.
much required. Okay, so
Okay,
you
okay.
show a big data and they do not understand anything.
Yes.
There is no point in explaining them. So just start with the basics.
Okay. Then what about this Apache Spark, Kafka, all those things? Can we add all those things?
Yes, they can use Kafka, Spark, or they can use Hadoop, anything. You can explain everything, but I would suggest that you start from the basic. At least
Okay.
they should know the basics, and then you can, on top of it, you can use any one of these tools.
Sure. So pandas and matplotlib will be the first thing to
Yeah,
begin with.
first
Yeah,
things
okay.
they should know. Yeah,
Thank you.
that's
Thank you.
easy. Yeah, easy, and everyone can access it. Yeah.
Yeah, definitely. And what are the other open source tools you strongly recommend? Because nowadays, we are moving towards open source in education institutions. And what are the tools you recommend?
For visual, you mean for the big data analytics?
Yes, ma'am. Big data analytics.
You can use Spark. That's good.
Okay.
Or
Okay.
you can use Dask.
Okay. Yeah. Spark and another thing. What is it?
Dask.
Okay. Thank you.
Okay. Shall we wind up the session? Okay. Thank you, ma'am. Thank you so much.
Thank you so much. See you on session 13, I guess.
Yes. We'll meet you again. Thank
Okay.
you, participants. Thank you. Good night.
Good night.
Thank you, ma'am. Good night.